See, okay, yeah, this works.
Okay, good.
And then, do you want to test out to see if you're, because you're going to be up first.
And yeah, we won't need the cards or anything for this one. Okay. So which microphones do we have? We have the lav and we have this one. Is this one currently a microphone? Nice. Real shit.
I talk so loud anyways. Really don't listen to me. But I know.
Where's our
What? You probably need to be standing today.
That's fair. So you've got this one microphone?
We have the one microphone and then this.
Oh. Since I'm just kind of doing
It might, I mean, it probably will be easy. If we just put the microphone at the thing up front, it might be easy. I don't know.
If you take this.
I'm gonna turn this off for now because I don't know.
Does this sound okay? Okay. Yeah, it's connected.
It is, but is what you're plugged into maybe just a power source?
No, because my laptop knows it's a video device because it changed that. And I'm also just plugged into HDMI. Do we have...
There should be a tech person.
Where is the projector? Oh. No, it's not running. That's just off of a windshield over there. Sorry, everybody. Usually the projectors have to be on. Phenomenal. Creative thinking and problem solving. Phenomenal. Okay, and then we want to arrange them so that that one is on the left over here. And I don't know how to make it full screen. And this one goes here. The speaker notes. Okay, that is actually functional. There you go. Alrighty, everybody. We're at the beginning of our time slot, so I'm just going to go ahead and get started, and as people filter in, we'll catch them up to speed. I'm actually kind of excited that we have a smaller group, because then we can discuss the things that you see in the presentation that you might want to expand on a little bit more in detail, and that's always super exciting. So we titled this project Insight Out of Chaos, Community Data Analysis Tool Workshop. And it's a pun that we're surprised no one else has made before that we're aware of. The objective of our work is to find insight using the data analysis brain share that Chaos has, so applying metrics and knowledge models to open source communities, but also to find new insights from the overwhelming amount of data and information streams that open source communities generate. And the way we're going to do that today is we're going to show you the tools that we use to make that happen. Here's a little reminder of the technical requirements for the follow-along component of this talk. We're going to need Docker and Docker Compose because we're going to be bringing up a multi-container application. And then obviously Git, which hopefully everybody has on their laptop, to clone the repository where we have all the source. And then for the second part of the talk, we're going to need some relatively modern version of Python so that we can hopefully avoid any package discrepancies. But I don't know how optimistic I am on that particular thing, so if we have any issues with that, we can settle on a virtual environment version that makes sense. And then we'll need Jupyter Notebooks. Jupyter Notebooks will let us go through an analysis project together step by step so that you can take that with you when you leave, and maybe play with it and get involved with the community that way. Who are we to be giving this talk in the first place? It was on the initial slide, so I'm going to go back to it with our names, but I'm James Kunstl. I'm a software engineer in Red Hat's open source program office.
I'm Callie Dolphy. I'm a senior data scientist in Red Hat's OSPO. And yeah, we're both a part of the community outreach team within our OSPO, and specifically, we are the 2 of 2 for the data team within that.
And so about 2 years ago, 2.5 years ago, under a different name, Callie started OSS Aspen, which at the time was called Project San Diego, which has been the name that it has been in different conference talks. And from there, we have a couple of different repositories named 8Knot and Rappel, where we do all of our work. It's all open data app development and open data analysis. So our team's day job, our responsibility is to assist and support a variety of personas in the open source software space, particularly in Red Hat. Community architects are kind of our bread and butter. They're the individuals that we work with day to day and who we learn from. Business leadership frequently have questions for us. Technical contributors to projects have questions about how their decision making will impact communities. And finally, community members. We talk to community members pretty frequently to help them figure out what the right move might be for their community at a higher level. And we help them by providing data science resources to understand and to make good decisions about communities in the context of their role. So someone who's in business leadership has a totally different perspective on community than someone who is strictly a community architect versus a community member. So we help figure out what the right strategy is for a community in their particular role. And in this talk, we want to share our process for doing this and the resources that we have so that more people can get involved in this space. Our fundamental objective is to support community sustainability by preparing and upskilling community members to make more data-supported decisions. So bring data rather than gut, or really not replace gut, because gut is really, really important when it comes to community data, but bring data into the mix so that people can see a higher level perspective on community. We're going to pause for just a second and get a survey of the room. Like, why was this workshop appealing to you. And all honest answers are accepted. It might be that you didn't like PG workshop or the Kubernetes workshop. We're just kind of interested in like what the level set is, who you guys are, and what would you ideally like to get out of a workshop like this. And then we'll share our objectives and we'll try to meet in the middle so that we tell you what we think is important from our experience and also maybe put more pointed emphasis on stuff that you're interested in. So anybody who'd like to volunteer their perspective, we'd love to just raise your hand and we can talk about it. Yeah.
So I'm a computer science student. I'm just interested in data science. So
Cool.
I'm really excited just to be here and see what you guys do and have to offer and
Awesome.
what I can learn.
And for the recording.
Yeah, I was just gonna say, we designed 8-Knot very specifically that the barrier of entry, especially for like people coming out of school or specifically data scientists, to be really low. We'll go into this a little bit later, but it's very modular, and there's only, like, you can, okay, I wanna work on a visualization. Here's the files that you need to touch. Here's the process that we'll need to be able to do. And actually 8-Knot is used in some like entry-level software engineering classes for people to like get their first taste in how does the process committing to GitHub work, how does contributing upstream work. And so I'll be curious to hear your feedback at the end of this of how accessible it really is.
Anybody else? Thank you so much. You're what? Cool. Okay, phenomenal. Yeah.
So I work at SCaLE, and we contribute to a lot of open source projects, and so what appealed to me was talking about that and pulling analytics, and then we also need to present that somehow, so you guys gave a great example of like, oh, we need visualizations, things like that, so knowing the toolkit that you guys use is really
Yeah, fantastic. And I think that we'll be able to really help with that because a lot of what we do is like multiple levels. Like, okay, do you just need data that you really can work with and trust? Do you want to go that next step further and have pre-developed visualizations that you can consume and just use? And then the next step, which Callie will cover, is how do you then extend that portfolio that we've developed that we think kind of covers the table stakes of what most people need, or at least most of our stakeholders have needed so far. And then how can we extend that next step? So that'll be the later portion of this talk. So we hope that's really helpful for you. Cool, thanks for sharing. Anybody else? No sweat. Cool. Thank you so much for those who did share. Here's what we wrote down initially that we really wanted attendees to get out of this talk. We wanted to level set a little bit in the first place and understand the motivations and novelties of the tools we develop. The two tools that we're going to be talking about specifically are Augur and 8-Knot, just to use the proper nouns. Then we wanted to give you a working knowledge of how to get 8-Knot running for yourself, which should be super easy. We've designed it so that if you have Docker Compose and the right credentials, it's just immediately possible. We do make the assumption, however, that you have a publicly available Augur instance, which we provide in our project documentation, and we'll share the credentials with you to access one that'll be available for this demonstration. But in the future, usually for any specific team, it's nice to run your own. And we're working with the upstream community maintainers on that to make that even easier to get running. Then we're going to go through and provide a framework to design a visualization or a brand new metric that addresses a question that you might have about the open source software or about some OSS community. We've already developed that visualization walkthrough so that it's fine-tuned and it's ready and consumable, but hopefully you can apply it to another idea that you might have that you see in what we've developed and you're thinking, oh, I really want to see this thing. How can I go make that happen? We'll go through our framework of how we choose specific metrics, and specifically we'll intersect with the Chaos project, which is, I actually have never said it out loud. It's a community health metrics project. I don't know the full definition though. Like, I don't want to short circuit the whole definition of chaos. That's what I thought. Community health analytics for open source software. It's one of the most fantastic resources for getting started in this space because it gives you like the first 99% of thinking about how you can approach a community health problem or try to understand something in a ton of depth. And it's a bunch of documentation by really, really, really smart people.
I was going to say for this workshop, the things that are under the Chaos branch, the Augur project, which we'll go into, and then specifically looking at their documentation around metrics and metrics models and how that goes into choosing what visualizations you look at and then how to develop your own visualizations. From my personal experience with like a lot of these visualizations, I'm like the data scientist who made them. The technical side of like actually coding it is honestly probably one of the easier parts of it. The developing the idea out from I have this question or even what is my question to what visualization should I make is much more difficult than I think people put credit towards.
Absolutely. So we'll show how to get one of those visualizations running after we've digested the information that we can find in Chaos and then apply it to a problem. And then we'll show how to complete the loop. So we have a visualization, like we've already ready-baked the thinking of what kind of problem we want to address. We know how to actually get it running in a notebook. How do we add it to an instance of 8-Knot and connect 8-Knot to an available Augur instance? Here's a really brief overview of the timeline today. These numbers are pretty much made up. Some things will take longer, some things will be really, really, really fast. All depends on how things go. So, meat and potatoes of the talk. Our motivation with this whole project, the whole, like essentially our day job, is that there are challenges with working with open source communities at scale. When you're an organization or you're a community member, really the roles aren't hugely different. Many corporate relationships with open source communities end at consuming the software and the documentation that the communities are generating, that they're creating, and that they're working really hard on. And part of the reason that it ends there is because open source communities are challenging to understand. Like when you're a brand new person, or you're a brand new contributor to a project, it's really hard to dive in. There's a lot of documentation to read, there's a lot of code base to read, there's a lot of people to know. It's really not easy to get involved unless you can maybe interpret things from a higher level. Going beyond consuming these resources as just a consumer from the perspective of an organization requires a more fundamental understanding of how a community works. And so addressing that gap from our perspective is bringing data science into the conversation. There ought to be a way to aggregate the trends that we see in communities and visualize the trends to find meaningful ways to promote community sustainability that's grounded in professional community architect strategy. Forgive me for literally writing down what I'm saying, but I want these slides to be able to be consumed later rather than just bullet points. And finally, business decisions need to be in conversation with the realities that a community faces. This will hopefully prevent missteps and optimize for the shared future where a company can be invested in communities. Communities can feel that like they're being heard by the company that consumes their resources, and a more equally profitable relationship can go forward. Principally, we use two tools to help make this a reality. The first part is a data collection and engineering application called Augur. Augur consumes Git, so repository data, and GitHub and GitLab API data. It's one of the projects in the Chaos project, and I think unambiguously it's owned by Professor Sean Goggins of the University of Missouri. 8-Knot is an extension of Augur. It's a data visualization and analysis application from us in Red Hat's OSPO, from us, the community data team. Those are our names. So Augur started out in 2017 as a research project in Chaos. The core objective of Augur was to prepare open source software project data with traceable provenance and a high degree of verifiability. We were talking to Sean, and his quip was, quote unquote, somehow this was very interesting to numerous organizations, OSPOs, and communities. Augur has participated in Google Summer of Code for, I think, 5 years. It's had a lot of contributors. It's a major part of the Chaos project, along with other great projects. Here's how Augur works in the abstract. So I'm going to kind of break from the slides a little bit and just talk ad hoc. First step is to, for a given Git repository, clone that repository, and from the available information there, start building out a table of the contributors to the project based on the Git commits, the commits themselves, and the available files in the repository. So build out the file tree, see who has contributed to which files, who those contributors are, at least the information we can get from a Git commit.
It's actually from a API.
I thought that they cloned it. This is a different conversation that I had with Sean.
Oh, maybe I'm wrong.
Yeah, it has to mine certain things locally because they're not of it. Yeah. So it's two major pillars.
From like the GitHub
Yeah.
API. And if you've ever worked with the GitHub API, it's like traveling a very wooded and unknown forest because
Right.
it's very minimal.
So then the second step, so we have everything that we could ostensibly mine from the Git repo itself. Then we go communicate, or Augur communicates with the GitHub and GitLab API to flesh out more of the auxiliary details. So we collect event data primarily, pull requests, comments on those pull requests, what kind of comments are being made on pull requests, issues and all the comments on those, labels on issues, etc. That fills out a baseline, high-level perspective of community and the source code that the community works on, and then a suite of day 2, so not immediate, like not the primary collection, but the second degree of analysis. Workers are run on that data, which provides stuff like the OSSF scorecard and other really useful metrics. This is a really high-level architecture of how Augur works. There's an Augur tool, which is quote-unquote Augur, and there's a Postgres database, which is what Augur writes to, and that's the consumable resource from the work that Augur does. All of the second-day data analysis goes in the database. Communication with GitHub and GitLab is the external interface that Augur has. So we don't go communicate with Augur, we look at the database that Augur fills in. This is a more expanded technical architecture of how Augur works. So let's go through the life cycle of a brand new request to Augur. And that kind of request could be, I want to do a full stack collection of, let's just take an example, like the containers Podman repository on GitHub, or Docker, or whatever. So we schedule a task. That was loud. We schedule a task, and one process worker picks up that task to clone the repo, mine it, etc. And then the data goes through multiple validation layers and finally gets populated into the database. It's a relatively simple flow with a ton of engineering behind it. Sean has said it before that it's mountains, it's tons of data carpentry on top of mountains of data. So in the end, we have an excellent consumable resource. I want to take a pause to go look at Augur's schema so you can see kind of the high-level boundaries of what data is available that Augur provides to a relatively well-filled-in instance. Starting with the schema. And I hope this is okay on this projector. So this is the big blown-up schema view of Augur, and I'm going to start in this little quadrant where we have data on commits. So commits are referenced by a particular repository, commit hash, author name, author raw email, etc. I won't do it. Yeah.
Have people here ever seen a database view before, like this? I just forget.
Yeah,
I just
that's a good
wanted to. I just
question.
wanted to take a quick.
Yeah.
If there's just,
Sorry about that.
it's all little lines just show how all the different boxes are connected.
Right.
So I just wanted to make
Key
sure we were good.
relationships. So I'm just doing kind of a whirlwind tour so you know the boundaries. So we got commits with all of the data that's necessary to describe a commit. issues, contributor affiliations, if that information is available from GitHub, contributors. I'm going to go out here and look up here. The yellow boxes are usually the ones that we work with. Pull request commits, so a back reference from a pull request to the commits that make it up. Pull requests and all this crazy amount of data that describe what the actual particulars of a pull request mean, etc. You could go crazy in the schema. And then going another step, come over here, mouse. Looking at the data just from dbeaver, so you can see the tables that are available linearly. And exactly from the schema, for instance, commits data. And indeed, we can look at the available data and look at an example of a query. Commits are identified by their hash, so those are like each hash per commit is unique. We have the author name if it's available, author raw email. You get the gist. This is the kind of data that's available in Augur. Just so that when we go on to the next step, which is visualization, you have a clear picture of what data model we're working with under the hood. So ideally, now we have a database, and we're just going to say, okay, this exists, and we have a lot of great data about communities. The particulars of how Augur does all the verifiability layers and the validation is out of scope for this talk, as is getting Augur running, but the docs are very good for that. So we have all these events, we have commits, contributors, etc., but it's just a database, so we need some tool to analyze the data and prepare visualizations. And when we start talking about this, people have said, oh yay, another data analysis application. How is this going to be different from the one before, the many before? This is...
Hop in for a little bit because I think sometimes it's nice to know where the project comes from and how it's got started. And so in around 2020, I was brought into Red Hat as an intern. I was still in college, and I was doing a lot of one-off data requests for the OSPO team. And we were kind of all from a place of like, we've never done any of this. What do we want to look at? What do we care about? And so I spent probably about the first 6 months just doing those one-off requests, like building stuff out directly from scratch for every single question that was had, and spent a lot of time looking at the other tooling that was available and like looking at Augur, looking at a lot of the different stuff. And the biggest problem that I was having at the time was that I wanted to be able to directly access the data and to be able to like capitalize on the research and the work that's been done in data science and other fields. So pretty much looking at Python or R and looking at the 25 plus years of research that's been done. I'm like, how I need to be able to access this data directly before I can use these packages, before I can do all the data pre-processing and be able to develop those complex visualizations and some of the more goals that Red Hat had internally around the analysis that they wanted to do around our communities. And so that's pretty much how 8-Knot got started, was really just trying to take data science workflow and principles that were done in other topic areas and apply it to open source communities and see where we could go with it.
This is a more abstract version of that same story, but it's more of the technical considerations on top of what Callie's already said. So we went and built a new app from the ground up instead of taking advantage of some of the awesome things that already exist. And this is our rationale. So there are some absolutely fantastic applications for visualizing the data that Augur has in a relational database, specifically Postgres. Grafana, Tableau, and Superset, I've done a talk on this before, are absolutely fantastic. And what they do, where they sit in the stack, is they really solve SQL-based visualization preparation. So in the context where you have data that is in a SQL database, or a database that's accessed with SQL, you can prepare a visualization, and these tools are fantastic at that. But they don't support very easily, at least we couldn't do it super ergonomically, more like ad hoc visualization pipelines. And like Callie said, we really wanted to be able to leverage what we could find in the literature. So that would mean taking advantage of machine learning opportunities and using distributed compute, and specifically working with stuff in Python native pandas, because it's very accessible for people to come in and use what they already knew in school. So pandas is a huge part of that. So here, these were the packages that we were specifically excited about using and that we couldn't use in the context of Grafana and Tableau and Superset. So PyTorch, Dask, Pandas, TensorFlow, NetworkX, etc. So once we had committed to using some Python-based stack, we had to make a decision about how we were going to actually build a visualization app around that. There are awesome frameworks for doing this, and the way that we made our decision is we looked at the range of complexity. Streamlit, who here has used Streamlit ever? So I know how deep I should go. So Streamlit is really cool. Streamlit is based on the concept that if you have a Python script, you go from top to bottom logically, and in Streamlit, each part of a page on an app gets rendered in order. So you can use any Python tools you want to render out a relatively simple page, and so for most applications, that's more than sufficient. You have access to the full Python data science stack, you get a really pretty performant web application from it for data visualization, but on balance, we decided that it was a little bit more limited than we wanted, because we wanted to have more user extensibility. We wanted users to be able to have their own accounts and create groups of repositories and stuff like that, so that wasn't an ideal fit. The next level up in complexity was Plotly Dash. Most data scientist personas are very familiar with Plotly, and Plotly started building this web application meta framework called Dash. I'll get into those details in a minute, but spoiler alert, that's what we ended up picking. The most custom option that we probably could have picked was React plus Fast API, or React plus Flask, or any front-end UI framework plus any Python back-end framework, realistically. But neither Callie nor I at the time was a UI designer. We aren't now. No. Which will be very apparent when we show you 8-Knot. And so we made the concession, okay, we're not going to roll our own UI from top to bottom. We're not going to get super into back-end. We're not going to go that far at that time. So we trade the convenience of declarative Python UI development, and I'll show you what that means in a minute, which is inevitably slower than client local JavaScript UI code, for the unrivaled ergonomics of the data analysis integration that Dash gives you. And again, I'm just speaking in the abstract. We'll see that literally in a minute. So the final conclusion was that Dash was the ideal candidate for this. And this is kind of the data flow in the abstract for how Dash works. There's one common React front end, and for every Dash application developed by everybody, it's the same. And its job is to consume information from some Flask backend, or I think Julia and R are also supported. And so it takes some piece of information that says, this is the name of the component, these are the styling things for the component, this is the data that we want, and then the React front end just renders it. So all of the UI reactivity to the user and everything is driven from the back end. The front end is pretty thin. It's relatively slow because user interactions are done over the wire, but it's also really easy to work with because we didn't have to go learn React to get this thing booted up. It was very nice. This is how we manage scaling this visualization task set at a higher order of abstraction. So we have the application server, which communicates with two caches, one cache that does back-end processing for visualizations for us, and another that goes and collects data from Augur and then caches it. We'll see a literal representation of that a little bit later. But the fundamental thing to take away from this is that 8-Knot is capable of scaling pretty arbitrarily for the amount of data you need to collect and cache and the amount of analysis you need to do for incoming consumers, and that's a lot of the Plotly Dash architectural framework that's available. So building this as a meta application where we use Augur as the data backend and 8-Knot as the visualization front end looks kind of like this. So 8-Knot queries data from the Augur database, caches it, and analyzes it. The user communicates with the Flask backend with this React UI. It's all very nice and convenient. And the key observation for this is that 8-Knot communicates with Augur over some arbitrary distance. The expectation isn't that you deploy Augur and 8-Knot together. You can use one common Augur backend for any arbitrary number of 8-Knot instances. And we haven't built 8-Knot with the consideration or with the expectation that Augur is going to be running side by side with it, which makes it really convenient for anybody to deploy their own instance of the application for their use case. So as promised, we're going to go through a little demo of actually getting 8-Knot booted and then do a little tour and show how we connect it to Augur and how we can work with some user accounts. So if you're a user and you want to see a specific slice of repositories on aggregate, how you can do that. Do you have a note?
All of the links are on the, are like SCaLE, pretty much if you look at on the SCaLE website, on the schedule, there will be a doc with all of the links. I wasn't able to figure out how to do public sharing, so everyone please request. I'm just gonna be sitting here on my email waiting for those to come in, for then everyone can get access to everything. But yeah, all of the links from now until the end of this workshop should or will be available on there.
And I'm going to figure out real quick. I'm going to mirror my displays so that we can work together on this. Okay. So I,
Let's give everyone a second
yeah.
to be able to clone.
Well, I'm going to go through that too. So I'm just starting from an empty-ish directory where I've already moved the configuration files that we'll need into it, just so that it's easier and you don't have to watch me copy paste, but I'll show you where we get those environment variable configuration things in a sec. So first step, I want the slide back. I don't know where that slide went. In the links, we have a reference to our source repository, which is OSS Aspen 8-Knot. And we can clone that. And I'm just doing it into. Oh gosh. An access request?
Yeah, so I'm pretty much having to go one by one.
Oh, I see.
I'm sorry, I missed the link to that.
The link is in the invite, or in the event. So if you go onto the SCaLE website for this, and so we have it linked in there. And so then that's the one link. When
Yeah.
someone gets access to it, all of the stuff that we do from here will just be in that one document.
The ergonomics of sharing a document from the company Google Drive are not ideal.
Is anyone still waiting for link access?
Just requested it.
And if there's any point in the workshop from here on where you're like, please wait, I don't know which link, please just raise your hand, stop us. For then, I don't want you to get behind,
Yeah, absolutely.
confused.
And if you're doing this on a Mac, just want to take a sec to say, start the Docker desktop application so that you have Docker running. And if you're on Linux, you already know what's up.
How many people have Docker on their computer already?
Fabulous. Okay.
move forward with the workshop.
Okay, so change directory into the 8-knot directory. And I think it comes by default on the dev branch. Could you confirm that for me? So it starts on the dev branch, which is where we want to be. And I have already prepared the environment that we're going to start out with. So I'm going to copy it here. But this is what we're expecting to have for this demo. So all you have to do is create a file called env.list in the top level of the 8-knot directory with these credentials filled in. And all of the credentials should be in that shared links document up at the top.
There's also a file that needs to download as well.
Don't share our passwords with anyone.
Super secure password.
They're very secret and proprietary. Right. Anybody still need a sec? Okay, cool. So, funnily enough, we've done the hard part. The only thing that remains, I'm actually going to clear the screen so that's the top. Okay, this is my recommendation for like a development scale of 8-knot locally. I'm gonna make that bigger. Oop. Sorry, that went to the bottom. Cool. And then when you run this, it'll take a little while to get it all built. For me, it's instant because I've already built this.
But the exact text to go into the terminal is a one.
Yeah. And you are fine if you just do docker compose up -- build. Scaling just makes it a little bit faster. Whose Docker is still building? Cool. Awesome. Anybody already done and you see like all the pretty colored text? Cool. Everything going okay over here? Oh, inevitable.
We have a little bit of time with this stuff.
Yeah.
This is like the hardest touch point, and so
Yeah.
everyone who wants to be following through, like on their computer throughout this entire one, like raise your hand, let us come and help you. Like let's get everyone's Docker this stuff working, and then everything else is pretty is pretty a lot easier from here. Which is the biggest touch point. You see your Docker's not working, would you like help getting your Docker working? Yeah. as I volunteer.
Yeah.
Our communal software engineer. Oh yeah.
Oh, sure. I'm still going to take the lab off. Yeah, just bring it in.
So it just gives me a help command.
Oh, gotcha.
Am I just doing something wrong?
Unknown flag -- build. Oh,
I tried this one as well.
yeah.
Just give me the same thing.
Is Docker desktop on your computer?
I'm downloading it.
Oh, then it might.
Oh.
But I just use brew to install it. I don't know if it.
So you've got, yeah. And is that currently running? Like you're currently installing Brew?
No, it was already done before this started.
How are things? Is it running for you? Yes, no, no? What's going on?
I've just never used Docker.
You're lost? Okay, I
Huh?
I feel
I don't know.
I've never
We'll
used Docker.
see.
No, that's the whole point. So, or brew.
I installed both.
Yeah, sometimes. So you got both. So we need.
Windows. Cool. We'll see. We'll see. I think I'll honestly be able to. So just pull up the. Do you have access?
So
might require the
I was
cat.
also installing the desktop as well.
Oh, okay.
Yeah.
Oh, perfect.
I wasn't sure. That was just the Jupyter notebook.
I work mainly, so I'm assuming that's me.
So this is Docker Dust. So you should have it.
So yeah, I just installed everything else,
Go into your terminal and
but I
your
didn't install Docker
VS
desktop
Code.
that way. So maybe that's why.
And then
Yeah, let's see.
be pretty much
So yeah, Docker Desktop just makes everything really convenient.
Okay.
because he would know more so than
What's
I
the
would
difference?
of what
So essentially, Docker on Mac requires that we run a virtual machine because Docker processes like containers don't work on Mac. So we run a Linux well, it's just one of the primitives of how Docker works. It
Okay.
like containers require Linux things.
Yeah.
So we run a Linux virtual machine, and then Docker Desktop is the convenience.
Looks like it just downloaded.
Yeah.
these are like good things for us. Y'all are our architects. This is a great way
That's
for us to
annoying.
know when things are, how does it, just for James, do you work on anything specifically for like the assignment?
Yeah, I am.
Okay, I guess I want you to see what this is, just.
Yeah, I just want, so what I'm, yeah, give me a sec. Right now what I'm just doing is your Docker is not, or your brew is not picking up the Docker repo.
And it's fairly updated.
I mean, you got the M3, right?
Yeah.
Brew installed on desktop Mac. I mean, it should just be available.
Yeah, so I have it downloaded in like downloads down there. It's already part of that PMG. Yeah. Yeah. There you go. So that's what I was downloading in the background.
Oh, I see. Yeah, I don't know if this is,
So I just clicked the link that's in the doc.
oh, frame up. Gotcha. We shall see what happens. Should work.
By the way, locals be on there.
All right. Okay. So resources, we're going to give you 8 CPUs, we're going to give you 18 gigabytes of memory, and we're going to give you 4 gigabytes of swap. Resource saver.
So that's kind of why.
Sorry, I shouldn't swear.
That's okay.
So you'll just have to remember that when Docker is running, it's consuming this much of your laptop because it's running a virtual machine that big.
Yeah.
So now we have that. Let's see. There we go.
For whatever reason,
I think maybe Brew doesn't have Docker Desktop as.
Just pull down like I install Docker via Brew, and all it does is just install Docker Desktop,
that's what I would expect, yeah, but it didn't do it for it. I don't know what the deal is.
There might be a different package name.
I thought maybe the repos were out of date, so it didn't. I don't know. This is beyond my awareness. But yeah, so
Cool, so I'm good, I'm like caught up.
you should be good. Like this was the hardest part.
Okay.
Did you have the task?
Yeah,
We
yeah.
tried, yeah.
Nothing. I don't know.
Weird. Thank you.
Yeah, if you have any further thoughts, let me know. Yep.
And this is why we hired a software engineer. Because before it was me, and I was like, this is not going to work out well for anybody. Yeah. Where? Good James, right here. Dawn, have you ever had it not running on your computer before? It's exciting. Yeah, this is gonna be great. Hey, and this is, and that's why I've pretty much been like, you're not the only one of being like, for this and for the one for OSSNA, there's a lot of people where I'm like, if you just want to get up and running and don't want to figure any of this out yourself, this is it. This will be the easiest 3 hours of your time to be completely set up and ready to go. Oh my God. I'm excited. I think I'll be very curious to see what your thoughts are about the first response visualization, because we're literally going to be diving super deep into that one, because like the puzzle piece slide that I do it for ours, that's pretty much, we're doing that live. We're taking the pieces of two and switching out PRs and issues to make a new visualization, because then you're able to kind of see the power of having a structural database and being able to see, okay, I want to see this visualization on a similar but different amount of data. How quick you can just switch things out, and then you have a whole new visualization, a whole new view of things. So. Should be fine. If any of the people if you're not able to fully build, if you could open an issue on 8not documenting what your setup is and just screenshots, that'd be really, really great and helpful for them. We can actually spend some time figuring out why that's happening if we're not able to fix it live. I know that's not super helpful for you right now, but that is very helpful for us in making sure that this is yes. Because I mean, we both have the same exact computer setup, so it makes it, he's really good with doing a lot of different virtual machines and trying things out, but in the day-to-day, pretty much most people who are working on it are on Mac and the specific, the same chip and everything, so the problems you'll run into on different computers, new. But I mean, seriously, you do. It's gonna be great. It's so helpful. Yeah, you're good. I know you're good. I saw yours. That's the funny thing is when it works, you're just choop, and then you're done. And then whenever it doesn't, you're like, I don't know if I can ever make it out of the black box. Okay.
We should cross-validate on other operating systems and stuff at some point.
That's why I was pretty much doing a call for if anybody's isn't working on it
Yeah.
to just screenshots your bill.
Yeah.
For them, we can go through all of that later.
Yeah.
Especially if because we can go through that before OSSNA.
Yeah.
Oh, yeah. Yes.
Okay, for those of you who have gotten past the build phase, we can have the payoff, which is going to any local host, so 0.0.0.0 or 127.0.0.1 or the worst or the local host.
Have defined, and this is the predefined one, isn't it? 505051 or 50.
No, I'm just saying any host, any local host, and then port 8080. And that's where it lives. And then it'll start saying this, essentially oh, we're collecting stuff. And that'll take a little while.
The first initial build takes a decent amount of time to be able to do. But then, for example, if you're developing a visualization, you put it down and you're editing a file and you put it back up, all of the data caching holds until you completely destroy your Docker.
Right. We're going to expect y'all to clap like that. Not really. So in an ideal world, it is that easy. It's move your environment variable into the root and then compose it up, and it just kind of pops up for you because it goes and connects to Augur, If you have a problem, all of the visualizations when you go, or it'll like complain a bunch in the logs, but the visualizations will also go like nothing works. But it's less of a black box and more of a complain in one place, violently fail in so that it doesn't do anything dumb in the front. Like it'll complain like a developer would expect it to. But anyway, so right now, actually not going to pause. Did you guys make any progress over there?
Yeah, well, fingers crossed. If you help me out,
Was it the VM size?
probably clearing the cache.
Okay. Oh. Phenomenal. Okay, cool. And what about for you? Okay.
I forgot to do the cursor playground.
Oh, heartbreaking.
You think
You're still going to do it?
there's still time, which is
Oh, God. What did I do?
right now.
Okay. There's just like there's a mysterious black control up here that's very sensitive. Okay, so we'll just keep moving forward here and do a little tour of the visualizations that are available out of the box. That's where I'm going. So there's a lot of features in 8.0 that aren't immediately obvious because they're either baked into Plotly or they're not enabled by default. So we're just going to do a little tour of what those are so you know where to get started with them. So using any individual visualization, we're going to use all the nice features that Plotly gives us. So we can focus in on an area and that'll select a smaller window of the data that's available. Double clicking on it will exit the focus, so we go from zoomed in to zoomed back out. We can deselect categories of data by clicking on the legend, which is over here. And then we have a little toolbar up at the top, which is up here. And this will be clearer in full resolution. But we can do a bunch of stuff with it, scale, take a PNG, etc. And then we have a little card at the bottom of every graph that describes what the graph is supposed to be showing, and like our very abstract interpretation of how you can use it. This goes into a breakdown of what each of the individual pages are kind of for. Generally, it's hard to categorize these visualizations into like one specific angle or facet, so these are very gentle divisions, mostly so that no individual page is super overwhelmed. We have a separate section of what?
I was going to say, if as you're going through these visualizations, different suggestions on how we should group them, or what would make sense for you, this is another, please open an issue, this is something that we're really trying to work on, and you'll probably hear me stop throughout the rest of this presentation of places to where we're really looking for feedback to help develop this project.
And then we'll see this in a minute. Well, we have Augur accounts. There's a notion of using Augur as a user preferences backend, which is very convenient. So like I said before, you can group different repositories together. So if you're always going and checking out the 5CNCF project, or you're always checking out your group of projects, you don't have to always put them all in the search bar together and waste a couple cycles on that.
So why doesn't this default running locally have that on in Augur one?
Right, so in general, we make that an opt-in thing. The reason that we didn't configure it, and we will configure it in just a minute to do that, is because it requires a lot of configuration stuff that supports this thing called the OAuth 2.0 flow that we don't want to just like dump on you out of the gate. We have to specify a ton of URLs and go through the process of linking your app to Augur in a reasonable way. So we're just starting with a clean slate. Good question, though. And then this is just like how you go add a user group if you want to add a new group for yourself.
And when you add a user will trigger collection. So instead of needing to go through a whole lot of stuff on the Augur side to collect on new repositories, you can just add that to a user group, and that will start having, we'll start collecting on those repositories. So if at the end of this workshop you're like, I don't want to do any of this myself or host it, but I just want to use this platform, there's a hosted instance of it, and if you want repositories that you specifically care about in that database, you can add them in by using the user groups.
Yar. So by default, in the configuration that we gave you, we're starting with the target repo set organization as the chaos project. So that lives up here. If we want to select another thing, like chaos augur, for instance, we can go select it like this, and it's the GitHub URL that points directly to it. Alternatively, if you want to slice by an org, like we have for chaos, there's like Kubernetes. Oh, wait, no, sorry. Kubernetes isn't available in this database, but we can look at other stuff like Swift Kelsey, for instance. I don't know what all the orgs are in here, but like, for instance, on our publicly available instance, we have like Kubernetes and Kubernetes SIGs and containers, etc. And then if you want Podman, container/podman, I don't know. Anyway, it's there. So we're starting off with the chaos organization, and we can break it down. So we can say, okay, in the chaos organization, this is the overview of the programming languages that are used. This looks at all of the files and breaks down their type. Augur does this for us. What the package versions are, like how old they are. And then below we have per repo analysis. So right now we're looking at Grimoire Labs sorting hat. But if we want to look at Augur, for instance, which is what Callie and I are most familiar with, Augie, let's see. Oh, nice. Augur. This one's for Augie. I think when we built this database, it didn't include Augur specifically. But here's the scorecard for it, OpenSSF scorecard, and some general repo. So what license it uses, if it has a code of conduct, whether or not it has like a contributors.md file, and that's how we check for this. Does it have a security policy, etc. And then we have a page that slices by contributor contribution statistics. We just call it the contributions page. Pull request activity, which includes some axis and concept of staleness, how old a pull request is. You can parameterize that for yourself. So you might say, there's no way I'm calling a PR stale after 7 days. It's actually going to be 37 days, and it'll re-render for you. And this errors and says, okay, days until staling is less than days until stale. So maybe we'll make that 60 days. And then, okay, our number of stale pull requests decreases relative because we increase the days until staling range, for instance. We can track the number of pull requests over time as a trend, merged versus closed. And I won't go into tremendous detail on each of these. Issue activity, how much issue backlog is building up in the project, and look at the trends to see how many issues were closed versus opened. We can see like, okay, the trend decreases dramatically, and we can see a bunch got closed. A bunch of issues got closed. Issue assignment status, etc. And then some of the more interesting, like deep dives on pull request conversation engagement are available. So as PRs get opened, how many are having a response, are getting a response from not the PR opener within 2 days, for instance, or say 20 days. This will take a little bit to render. You see, okay, pretty much the same case. Like we're not seeing a huge gap. And then we slice by contributor statistics. Some of these are a little bit more, a little too detailed to go into like verbally in this presentation, but we encourage you to go check out like the about section to see what the details are. But we can see, hey, new contributors by month. New contributor types over time. Are they showing up repeatedly, or are they showing up like a couple times and then leaving and we haven't seen them since? contributors by action type, so how many contributors were opening a PR in this span, April 2023? How many were reviewing a PR? Number goes down because there are fewer reviews than there are open PRs, etc. And one of the most exciting pages that Callie and I developed, and mostly Callie developed, was this slice of organizational affiliation in a given project. So we can actually take a second look exactly at what we know the most about, which is OSS Aspen / 8-Knot, so that's our project, which will go collect the data, cache it in 8-Knot, and we can look at what the statistics are and see, okay, Callie and I know exactly who contributes to this project, so we can inform what these things mean. Unique contributor email domains, so 22% of the domains are redhat.com, 17% are Gmail, users no reply github.com, other. You kind of expect to see these. Yeah.
I was going to say that this page looks pretty well at like the idea that a lot of times whenever it comes to community or anything that you're analyzing, you're not going to be able to directly answer the question that you would like. Everyone would love to know at the very, like being like, this is the exact amount of contributors that are, these ones are working at this company and these people are working as individuals. That's just not realistic. But you can look at different slices of it, look at, okay, how many unique domains are being used, what is the breakdown by the different types of contributions. You can look at it from a bunch of different angles and get a really good holistic view towards that, like be able to understand what the landscape looks like without being able to answer that direct question. And so I think this is like a pretty good example of the type of care and the type of analysis that's like what it actually happens and what is you're able to get to.
For me, one of the most useful examples of that is of this question, like the problem with the question of organizational affiliation and Augur's value proposition and the data analysis that we do is actually this visualization, where we try to associate activity in the project to individual emails associated with multiple emails on an account. It's a lot to digest, so I'll break it down. So in this visualization, we see this column where it says, okay, for redhat.com, there are 3,021 contributions. What that means is that in this project, there are 3,000 contributions attributable to user accounts that are associated with at least one Red Hat email. So that's ostensibly Callie and I. That includes issues, pull requests, commits, etc. The same is for this users.noreply.github, so there are that many events associated with an account that has that. So all of these columns are kind of double counting, but it gives you a really clear picture of, okay, this email domain generally is associated with this volume. And it could mean that someone could have many different affiliations, so I know that I'm a bu.edu email, and roughly 50% of my time on this project was using that bu email. And so that kind of makes sense. And then you can see like my MacBook Pro got put into the commit history, so you can actually see it. But it's really, really useful to see slices like this to help paint a broader picture of affiliation in a project. And then this is... Huh?
I was going to say that like the project velocity was like full chaos.
Yeah. So this page digests one of the cool perspectives that is available on the Chaos website. So all of these visualizations on this page, and we've only implemented 2, come directly from definitions from the Chaos project. So lottery factor analyzes the top 10 contributors by commit. So, excuse me. These commit hashes are respective of different individuals in our project, or excuse me, in Chaos, that have done some proportion. So they've done at least 10, or at least K contributions and how many they've done. And then roughly 50% of the total contributor base is outstanding. And then when we look at project velocity, we look at the axes of number of commits on a logarithmic scale versus PR and issue actions. And we can see, okay, up and to the right ostensibly means more velocity. So Grimoire Elk has 3,300 commits and 900 PRs. Let's see, where does Augur live? Oh, Augur's not in this slice. That's okay. We see like the layout generally of how big the projects are in the common set that we're looking at, how much volume of contribution they see, etc.
I would say that this is also a pretty good example about why we really wanted to use, and then we'll kind of this, and if we go through the code base page, these types of like more layered, complex visualizations where we're integrating, okay, we're taking into account PR, reviews, merge, issues, a bunch of different data contribution types into one visualization and able to weight those contributions in different ways. That's kind of the level of analysis that made us really want to use a Python environment. Because those type of things with the tool, like with a lot of the more built-in dashboard tooling that was available, we weren't able to do that aggregated analysis to be then populated into the visualizations. And I'll talk a little bit about this page as well. I think this is a good example of that next phase analysis that we like to talk about. This is a heat map series. You can look at the different about graphs, but it looks at activity in a repository, not just at like a higher level. It's looking at it as at a like directory to file level, and you can choose which view you want to have on it. But you can see, okay, how long has it been since somebody who's contributed to this section of the code? How long has it been since they've been active anywhere? Do you have sections of your code base that are in the contention to be unmaintained? Do you have people who are contributing a lot that maybe should now be reviewers, and you know that your reviewer base is going down because of the combination of these three different views on your contributor activity and your code base? And so this is like each one shows a different view, and put all together allows you to have the information that you would need to make preventative actions that could help your community out. So then it's not that, I don't know, 50 PRs are open to a certain section of the code base, and that's how you figure out that you no longer have a maintainer that is familiar or aware of that area, or if you have some people that you should probably be giving more responsibility in your community, giving more opportunities. And so this is something that we finished more recently, and yeah, I think that kind of shows where we would like to go with the visualizations and the analysis that we're doing.
Yeah. So this, wow, that was loud. This is a series of 3 visualizations that I would actually start with this one to like ramp up complexity from relatively simple upward. So this is just a heat map of activity in the code base by number of contributions. So this looks at PRs opened per subsection of the repo at a given level. So right now we're at the very top of Grimoire Lab Sorting Hat, which is a project from Grimoire Lab. And we see, okay, in the directory Sorting Hat, 1 PR was opened in September 2023, for instance. So we break it down by pure heat map. And then reviewer heat map looks at the same idea, but how many PRs were reviewed, targeting a specific subcomponent of the project. And finally, contributor file heat map is exactly what Callie was describing, which is the interpretability thing is kind of better verbal for me. So here we see, okay, the last time 3 contributors to the Grimoire Elk folder in this project were seen was June 2020, for instance, which helps you look at this and backdate, say, okay, last time we saw these contributors anywhere in the project to the schema directory was June 2020. And we can see, okay, these people are no longer showing up in the project, and identify, there's relatively few people for the utils package or utils subdirectory that have been around in a while. There's only 1 person that's been around. That could be a problem for us. And then for any definitions that you need for like inspecting these graphs, we have a page of all of the definitions that we use. That's a really big overview of the application. and all of the faculties that come with it without extending it to include Augur accounts. What I'm going to do now is, and I'm not expecting this to be a follow along because it requires going and essentially registering the app with an Augur instance, so we're just going to kind of skip that. And I'm going to just show it to you as an example. I'm going to rebuild. Oh yeah, I'm moving on in like 5 minutes. Yeah. You can force stop this stuff. This is my recommended way of bringing everything down. So Docker compose down -- volumes, which will clean up all of the Postgres cache things along with all of the running containers. Okay, whatever. So I'm going to copy back here to. So I have this new environment where I include all of the stuff needed for OAuth. We're connecting to the same database. What I'm going to do is use the credentials that I have for a previously registered instance to go communicate with the Augur registration endpoint, and then re-register this application as a net new thing. You'll just see what that means in a sec. So same way to boot this back up, just with different credentials. And now we have this new thing up here that has Augur login and sign up, refresh groups, manage groups, log out. All of those are disabled for the time being. And I'm just going to log out so we can start from scratch. So we go to this page, and we're greeted by the Augur front end. And the Augur front end lets you manage 8 knot instances registered with a given Augur database as extended endpoints, and manage your user groups, etc. So I have an account previously created with this. And normally, if we were just logging in, we would just do this OAuth authorization flow. But I'm going to short circuit that to go through the process of registering a new application. So I have this connected app that I don't want to use. We're going to create a new application. I'm going to do SCaLE demo. And the redirect URL is where the OAuth flow will try to go back to with a code that's needed to authenticate your user. Because I'm using this locally, all I need to give it is what the route is to my local web server or application server. So http://localhost:/, and we run it on 8080. Validating that, yep, 8080. And based on the definition that OAuth likes, the /authorize endpoint is what we make available. Create this, and I've got this new application, 8-knot SCaLE demo. I need to replace some credentials. We've got this application ID, and I have to bring down the web server to just restart this with the correct application ID. I can change it here, and then change it here, and then change it here. All we're doing is changing where it says like client ID or app ID. And then we need our app ID, or excuse me, the client secret. That gets replaced here and here. And that should be it. Then we can bring up this new application that's registered with Augur. Doo-doo-doo. We're just going to watch this connected users thing in a minute. And now we're authorizing our user account to go use this instance of Augur that we've registered. When we come back with our user account, we have my username, Jay Kunstel, up here. And here in connected users, it says, okay, we have one connected user using this Augur, or this particular Augur instance. So what's the point of these user accounts then? Well, like I've said a couple times, what if I don't want to always have to put in like OSS Aspen / 8 and OSS Aspen / Repel, our two projects. I don't want to do that every single time. So I have the ability to go into Augur and create this demo SCaLE group 2. You can see that I rehearsed this. So we have this guy, and we have no repos in this group. And if we add OSS Aspen / 8 and OSS Aspen / Repel to SCaLE group 2, we have two repos now added to this. We can see for Repel and 8 we have issues and commits associated with it. We know that the data is available. If the data is not available, then Augur will have these two as zeros, which just means data is collecting. We're working on extending that, so it'll say data collecting more literally, but that's just what that means if you see that. And then we can refresh the group, and then under my username, I have SCaLE group 1, SCaLE group 2. If I select that, search for it, we have these two repos as the aggregate set, which is really convenient because now I don't have to look that up again. And we've had some user stories where people want to slice, like I said earlier, specifically on CNCF incubating statuses, for instance. Same with the Apache Software Foundation. Like, want to see what the activity has been in the Apache Software Foundation attic projects, like the stuff that should be EOL'd. Like, are people still interested in that? That's a slice that people have asked for specifically. So that pretty much wraps up this part of the demo. My recommendation is that if you're interested in signing into Augur and going through this user groups workflow, work through the docs, see if there's something that's not ergonomic and you don't like it, and let us know. If it's great, also let us know, because we'd love to know that. Some things will probably be extended in the near future just for API simplification, like this will change because we essentially reference the same endpoints twice for two overlapping implementations of OAuth for different things that support both ends, or two contexts, so that'll change. But otherwise, a lot of things should be the same if you go play with it. Anyway, thank you so much for following along with me up to this point. Really hope that you learned something about the data visualization stuff we do, and you can go use 8 and contribute to it at your leisure, and then I'll turn it over to Callie for the second part of this talk. Okay, whatever. Do you want the lav?
I think I want the microphone. We're gonna see. I think that's gonna like bother. more at like a conceptual level, how would you start to build them out? And then we're gonna go from start to finish, building our own visualization, from taking in the chaos documentation, looking at some of the visualizations that already exist in 8-Knot, and taking all the resources that are available together to put and make a new visualization. But first, I'm going to talk about it more from a conceptual angle. And so this portion, we're just going to be talking about the value of community metrics, the methodology, and just the different analysis lessons learned type moments. I think this will be good as well for people who aren't as familiar with maybe community or community metrics at all, of like kind of some of the different angles that you might want to consider if you're starting to do community metrics on a community with a community that's never done that before. And so first, we're kind of looking at what can these community metrics start to enable. And first, we are looking at just building on the community knowledge. Like data analysis and this type of automation of getting this information is not going to be the one thing that informs your community decisions. It really shouldn't be. It should be something that helps enable them. It should take things, and this is something that I've gotten from experience of things that might take 10, 20 hours to manually look into, or things that if you don't have the data behind it, you will never be able to actually confirm. Those are the things that can be really helpful when you start to have this community knowledge. You take what you already know, you're able to confirm some intuitions that you have and be able to make better decisions and honestly quicker decisions. You can leave the step of discussing it. If something is happening, you're able to say, okay, I can see in X, Y, and Z way that this is happening. Now what are we going to do about it? Next portion we kind of talk about is staying informed in a sustainable way. I feel like anybody who works in communities or otherwise, we all have 1,001 things to do to keep up with. If it is not a maintainable process, if it's not something that you have time for, you're not going to keep up. You're not going to keep up with it. So a lot of the different visualizations that I think about making is about, okay, what is a large 20-hour process? Is there a way that I can make it a 5-minute process? And how would I go about doing it? And the last thing is just filtering through just the massive amounts of data. I feel like there's a lot of pressure to use data, to make data-driven decisions. You have all of this mountain of information. Now, what are you going to do about it? It can be very stressful and hard to even, I mean, if you think about the auger schema, you look at it in the huge view, and you're like, this is just the tables. Like, how do I even get started? How do I use this in an intelligible way? And so those are kind of some of the stuff we start thinking about. The next things is looking at what type of perspective you want to be able to gain or share by these metrics. And the one of the first things you want to start thinking about is your goal to gain information or to influence action? Is there an area of your community that's not understood and you're just trying to take that first step or getting there? Or is there like an initiative that you're trying to just decide on, or something that's already happening that you're trying to see the impacts? And so those are kind of one of the first things I start thinking about. And the second one is thinking about if you want to expose areas of improvement or highlight your strengths. There's times when you really want to hype up your community, show it how great it is. I'd say as a OSPO within a larger company, there are times when we want to be able to highlight just all of the wonderful things about X, Y, and Z community and really show it in a way that's accessible. But that's those type of metrics, looking at all of it from being the hype up, the things that make it look great. That might not be the same type of metrics that you want to look at when informing your community decisions. If you're trying to show maybe some shortcomings or trying to inform yourself on things that you could do better, looking at things that just tell you how great you are isn't going to really be helpful in that process. And so there's a time and a place for highlighting strengths, and there's a time and a place of trying to figure out where your shortcomings are. And the last thing you want to look at, we kind of go into earlier, is looking at community impact versus the business impact. Businesses are used to seeing numbers and data. I have seen in a lot of our conversations just having the data behind what we're saying whenever we're talking to more of the business-minded people within Red Hat. It is something they're familiar with. It's something that gets them to be like, community isn't this big, scary thing that we don't understand and super unstructured. Those are the things that make it seem more accessible and put value behind the things that we are saying. And then you can look at it from how is your community impacting open source overall? How does it look at the ecosystem? And so those are kind of some of the things you want to consider. And I would say these aren't always an either or situation, but these are the type of framing that you want to do when you're developing a very deliberate metric. And so for then it doesn't start getting, there's just a lot going on. So trying to really hone in on what your individual goals are for each visualization or set of visualizations you make starts to make this a more manageable process. So first, we're going to be like this portion of it, we're going to be looking at the codifying the projects and the metrics. We can talk about, like, debate. There's a lot of different tooling. We've talked about some of the different ones for this workshop. We're going to be looking at Augur and 8-Knot, but there's always room for debate on that stuff. But this section, if you use a completely different tool chain, all of the things that I'm saying still apply. And so right here is where we want to start thinking about what do you actually want to know, what data is accessible, and a thoughtful execution of the data analysis. And so we'll kind of go into some different analysis angles, and these are just some examples. There are a lot of different things that you can look at, but they can be kind of generally applied to different situations. And so first we have our scenario, I call it 1A, is that you're building off of current data analysis. You've already started to go down this path within your community of looking at different visualizations, and then let's figure out that iterative process to make it better. The idea here is to build off some of the more common or traditional open source community analysis, commits over time, that's cool to know, but what does that actually show you or tell you or give you any way to make action from? At that point, it's just a base number. And so let's say you have some of the examples, we have contributors over time. Say you have that value of knowing that there are 120 total contributors over the lifespan of an entire project. And that's a value you can put on a slide, but how do you take a step further to be able to make decisions off of it? And then, so this is like, the first step would be numbers over time. Then you could take it the next step further, and we've actually seen some of these visualizations, is looking at the active versus drifting contributors. From all the contributors have been active or have been involved in the project, how many of them have been involved in the last 6 months, last 12 months? Is that value staying consistent? Is your active contributor base going down? That now starts to tell you something more in depth about your community and being able to make some more decisions off of. If your active contributor base just got cut in half in the last year, something's happening and you want to investigate more. Another example of this is like the commits over time. You can start looking at the commits by maybe a subset of the contributors. That's the lottery factor or the bus factor. Is there a very small portion of your contributor base that is the, like, I don't know, 50, 70% of those commits? That's a lot to be on a singular person, and it's also a lot of risk. What happens if that person leaves? And if you don't know who that person is, that's also the first step, because you want to make sure that they aren't going anywhere. Or starting to be able to figure out how could you take their knowledge to teach other people, seeing who else is involved. The 1B of this, this is something that I've actually just started talking about, which is just building off of prior work. There is work from a conceptual standpoint under chaos. A lot of other people have made visualizations and metrics. And so from a conceptual side or from a technical side, you can start to take things from like a structural similarity standpoint. So I have a little bit of a visualization with the puzzle pieces where it all goes together, but you're only changing one part out. A good example of this is time to first response. What you can take what you do conceptually from PRs and apply it to issues. And whenever you're using a structured database like we are, that makes it to where even from a technical standpoint, and we're going to walk through this That's going to be our visualization we're going to build, actually, is how to take all of the code and how to take the queries and make that one change. So now you have a brand new visualization, and how to start taking in those resources to make a more complex visualization or more informed visualization, but also not to repeat work, because nobody likes that. Another way of thinking about this is from a data similarity. A lot of times from your visualizations, you might have a bunch of pieces that make, like for context, there's the PR review assignments. That was one of the visualizations. And that looks at the assignments per contributor. So you know if there's a vast majority of those assignments going to one contributor, trying to understand that the same data and pretty much the same code can be applied to do the status counts. So seeing, okay, over the span of a month, how many PRs are being assigned or unassigned at all. And so you're not looking at it from the contributor standpoint, you're looking at the editor. You can see by how long this is taking to load, why we use a materialized view, because it is a complex, like layering, because you have a column or not a column, but a row for every single message or comment, however you want to like think about it, on a PR. And it also will exist if there is no messages at all associated with a PR. Things are happening. So this is just to be able to see what that query would look like. So you have like your pull request ID, the ID of that repository, what the which contributor contributed or that's the contributor for the pull request, and then this is the message that is associated with that PR, and then the person who sent that message or made the comment, and then we have our information about when a PR was created and closed. So it's actually a little bit simpler to do it from the issue standpoint than the PRs because there is no reviews and issues. And so I'm going to do a little bit of black magic because I have a feeling that I will take. Yeah, as somebody told us in a company meeting recently, the baking show version of tutorials. And so I pretty much, when I developed this visualization the first time and went about anytime I do kind of make a new query, I look at the structure of things that I already know, and then I start translating. In this case, there's pretty much a direct mapping to, oh, wait, this is not the one that I wanted. Pretend like you're not seeing this notebook that I'm about to open. It definitely doesn't exist, and I'm doing this all live with you for the first time. That's the one thing the mirroring doesn't allow you to have any movie magic. So, well, this is the query that I was talking about. And if you look at it, it looks very structurally similar to the one that you just saw for the PRs. This is PRs, and this is the issues version of this. What I ended up doing to be able to develop this was I went line by line for the PRs version, and then I just did the translation to the issues table. So you can kind of see up here, like issue, pull request ID. Actually, I think I might be able to open this in a, no, sad. I was hoping it was gonna let me do a additional opening for see them next to each other. But we'll be looking at, you kind of like can be able to see, this is the pull request repo ID, the contributor ID, so on and so forth. And that's pretty much the exact thing that I did. I just looked at the PR table and I looked at the issue table and I did the direct translation over and did it to where we were able to get the messages, which is the comments that are associated with each of the issues. And so there's just it's pretty much a little translation from PRs to that issues building. So the next step in doing this, once you have your query that you want to work with, take this, And then we will put it into our Plotly tutorial notebook in the exact same way. There's a link directly in that document to the completed version of this, visualization notebook of any of the things that I copy and paste over you want to be able to do locally, or I can end up putting it in the document as well. Just communicate with me and let me know. So yeah, so this is what we have here. Now we have our import for the repo statement. We have our query, and let's run the query and see what happens. So if you've ever used Jupyter Notebooks before, when the number pops up, that means that that cell has run. And so now we can see, and that's the query that we saw in the database editor. So now that we have our query to work with, let's kind of go back to the resources that we have available to us and see how they process the information for the PRs. So I'm actually just going to go and take this whole process data section and go and put it in here. And so then we can all just take a look at the code that processes that query, the query of data that we just looked at. I've been talking a lot. I'm going to pause for a second to make sure people just keep on going. You're lost.
I have some issues with Jupyter Notebook and SCaLE version that is beyond the scope of this.
Yeah. I'm so sorry. The SQL, even with doing the build, did,
I installed some AI stuff, but upgraded a bunch of stuff to versions that are compatible with Augur.
yeah, I've told James this, that I almost exclusively like working in like virtual environments like this, so then whenever I screw up, I can just destroy it and have no consequences for my actions. Because I have completely, you want to know why I do this? I destroyed the filing system on my computer in college, completely, using Jupyter Notebooks. So that's when I learned that I needed to put myself in a playpen, and because I cannot be trusted with anything locally. So that makes sense. Please then, if you're not able to do it locally, you're going to be the person that's going to be following this the most. I know, stop me. Whenever you're like, I don't know why you just did this, Callie, just raise your hand and let's talk about it. Oh, yeah, we can do that. We can talk through that as well. Also, it might just be that a good idea to get a Jupyter Notebook environment running for OSSNA. We'll see. It's another conference that we're doing this at. So, a little bit of a content breather pause. We can get back at it. So we have our notebook. We're in the tutorial notebook that has all the structure here. We made our query to go and get the data directly from Augur. And now we are looking at the code that was for the PR's first request, the PR's first response, and looking about how that maps to issues. So if we just go line by line, this right here is just converting everything to a pandas datetime object. If you've ever worked with pandas or any type of datetime, it is a nightmare. And so I pretty much opt to always converting to a consistent datetime object to know that everything's going to play nice. And so we know we're working with issues and not PRs. So honestly, whenever I go about doing this, I'm just gonna see where PR is. And now we know we don't want a PR created at, we want just created at, because that's the data that we have now. So I'm just gonna go and change this over to created at. And then we're doing the closed at. And so the next step that we'll be doing is looking at this next line of code. And we want to drop the messages from the time before was the PR creator, but now we're looking at the issue creator. Because if we're looking at people's first response, we don't want the messages that say somebody opened that issue and they went and they were the first person to comment something, because what it always happens. We don't want that to be a part of our data, because that's not a first response, that's themselves. And so the next thing that we'll kind of go through is looking at, we want to sort all of our information and looking at it by sorting by that message timestamp, since that's the thing that we really want to look at. And we want to drop the duplicates because we're only looking at the first. So instead of pull request ID, we can see that we just want the issue ID. Issue ID. And then we want to be able to get that first and last element in the data frame. So we want to know which one was the earliest issue created and what was the latest issue created or closed, to be able to get that date range fully of, okay, what is the earliest issue we have, what is the latest issue we have, to be able to do the iteration across. And so looking at these comments, I'm actually going to edit all of this right now. This is why I just do a little comment. So then now we are editing all of the comments that go with the code, so somebody can walk through this the same way that I'm walking through it right now on this next visualization. So we're having a new data frame that, actually I went two steps too far, my bad. For now, with the earliest and latest dates, we're going to use pandas to get a date range. So this is pretty much going to give us a date column for every single day from that start date to that end date. And so we're setting up a data frame to be able to put all of our information into, to be able to build a visualization. And so we got that date range, and we're creating that into a data frame. And this is for then whenever we get down to this next step, and if you look at it for PRs, and then we're about to translate it to issues, we're gonna look at every single day and see for that specific day how many issues are open and how many of those have gotten a response within our defined timeline. So if we look at the PR first response one, the initial response days is 2. So we have how many PRs are open and how many PRs have gotten a response within that 2-day threshold. And so we're gonna go back over to here. Which one? This one? Oh, thank you. Beautiful. You can ask James. Spelling is really my strong suit. It's honestly where there may or may not be about 5 commits for this notebook. That was purely me trying to spell response correctly. I wish I was joking. So what we're looking at here, I don't know how familiar how familiar y'all are with Python, but this is pretty much just applying a function to every single row in the data frame. This is something that I started to do a lot with these visualizations and really allows for some more complex analysis. So we see here that there is a function that we're applying to the entire data frame. We don't have that function in our notebook yet, so let's go and get the PR version of it and start to dive into what that means. Where are we at time-wise? Okay. Can you give me like a 10-minute point from right here? Because we might have to do some more. Because I want to be able to show y'all how to integrate all of this into 8-Knot, but I also want y'all to know what the code means, since we're kind of just translating over. But we're applying this function to every column, and so we can look at what is this function in the context of PRs. So this function takes the date and determines how many PRs are open and how many of them have a response within a number of days, which is perfect because that's exactly what we want, except for issues. And so we kind of can start going through this pretty quickly. I'm going to do the same little plug and play of changing over from PRs to just the issues version of it, which pretty much just means deleting PR from everything. But pretty much what this is doing is looking at a singular day. We're dropping all of the columns that have been created or all of the issues that have been created after the date that we're looking at. We're dropping all of the columns that have been closed before the date that we are looking at. And then we also want to include all of the PRs, but in this case, all of the issues that have not been closed yet. Yes? Is that, then it wouldn't be open on that day anymore. It'd be closed, so it would never get past that second conditional. No, because we're only looking at what PRs are open on that day, and then as of that day, have they been responded to? So in the situation where the first response is a merge or close, that means that it's no longer open, so it wouldn't be counted in this scenario. Yeah, because I guess it's like we're trying to compare like how many are currently open and how many have a response within the time interval. And I guess that's going to be the difference between looking at something over a month and looking at something versus on a day, is that then, because in our scenario, that means that the issue is closed or the PR is closed, and so then it doesn't apply to this visualization anymore. But yeah, so we'll kind of go back into this one. We're looking at the PRs being open, closed, making sure that we're only looking at the ones that are actively open. And then for the ones that are actively opened, if they have a response within the time interval that we've defined, which is number of days. And so that's kind of what each of these steps is going towards. I'm trying to be a little bit more efficient with my time because I want to go more into the 8-knot side of things. But pretty much we can look at the overall this function that is being applied to each of the columns. And so that's how you'll get for every single day a data frame with how many are open and how many have a response. And so I'm actually going to pop over to the notebook that we have already built out, which is line by line what we just did, to save us a little bit of time. But here's that number of days. Here's all of the translation over. That's pretty much just as me removing the PR from every single line of this. And then you can see what that data frame looks like whenever you apply that function. And so you have for every date, you have how many are open and how many have a response within that, what we have defined as 2 days. And so that's how we get that initial data frame to be able to populate our visualization. And so the next thing that we'll be doing to populate the visualization is that I'm just going to take the code from the create figure section. Because this is where all of that code to go from process data section for every single visualization is where you process the data and turn it into a data frame to be put into the visualization. And then now you have your sectioned out visualization stuff to be able to build a Plotly visualization. So if we look at this and compare it to what we've done for PRs, kind of looking line by line, this is all in Plotly. One thing I find very interesting about Plotly visualizations is that you're pretty much just building on top of each other. Like you can say like this one's like a Go figure, or you can do a Plotly express visualization and define a pie chart, and then you can just start building your customizations on top of it, like updating your layout or defining their documentation is honestly phenomenal. And I just go and be like, I want to make my pie chart 20% bigger, and then it tells me exactly how I build that customization on top. So what we'll do here is go and instead of PRs, we're doing issues are open. The date, the open, the lines, we want the PRs to be issues. Response, PRs, issues. And this will make sense more when we get there, but we haven't defined a color sequence in this notebook, and we're just trying to make sure everything works. So then it makes the process over an 8-knot a little bit easier. So I'm gonna make sure this has all been run, because I don't think it has been. Yeah, this is the other notebook. This is what I get, but. Yeah. Yeah, you're right. Workshop. Because then it's in a different location. Cool. Just running all the same things as before, so we don't have to go through it. Let's see, why is it mad at me? Oh, because I haven't defined the. So that's what we just did in the other notebook. I just wanted to have something that was already pre-built so then we can actually work in 8-knot. So this is making the database, or not the database, but the data frame. And then this is going to build the visualization. And now we can see, okay, it's mad at me because I just went and took this directly over. And in the 8-knot, it's just DF, and this is DF responses. And so this is how I do the movie magic. And when I tell you this is exactly what I do every single time I make a visualization, I'm not being facetious. I'm being very literal, because there's nothing more miserable than working in like a full-blown, like any type of app development environment and then needing to go, like, if you've worked with any data pre-processing, there's so many little changes that you need to make, and if you have to build and rebuild every single time you need to make one of those changes, it takes forever. And so would you look at that? We got a visualization going that tells us with the number of issues that are open and then how many of them have a response within those 2 days. So we've got all of the bones that we need to go and make this, to be able to go and make our, to make 8-knot work. I don't know why this wants to save something. I don't want it to be saved. Oh well. I'm just gonna do this, but then I can delete it. No, never mind. So sweet, we'll go over here, and now I'm gonna go directly to the visualization template and start just going line by line down what we need to do. And first thing that I notice, and it's kind of in there, I'm just gonna hop over, is that we need to import that query, but we made a new query. So we have to go and also add the query to our, to 8-knot. So I just go and copy the query template, and we're gonna paste it in here. And that's the copy, and so right here, I'm just gonna rename it to issue response query. And so that first to do is replace all instances of name query. And so I'm gonna do and change this to issue response. Issue response, cool. I went through step 1. I want to paste my SQL query into this string, the query string. So I'm going to go over here, and I've got my SQL ready to go. And then we go in here, and it kind of says this as well, is that this is how our caching system knows which repositories. And so you just replace and instead of like a repo statement, we just put it right here. So instead of repo statement, like you would use in a notebook, it's just %s. So we've done that step. Now we want to go over to the index callbacks, and we need to import the query. So I'm gonna go here. I'm gonna go import queries dot issue response query, import issues response query as. So I do it there. I have imported it, and then I'm adding it to the list of queries that are going to be run on the build of the application. So we've done that. Now let's go to our next step. So we have done it, we've registered it, and now we need to go and create a table and DB in it. And so let's go over there. Ooh, where is it? There it is. And so now we want to add a table that is specific for this query. And would you look at that? The one that's right above is the one for PR response. So we're familiar that the structure is very similar. So I'm just going to go copy and paste it and take over and make this into an issue first response. Instead of pull request ID, I'm going to do issue ID. I'm going to change this to a text. We can explain why later, but I just know it's going to make it fail because the int is very large. And I learned that the hard way over the weekend. Big int, because I've been using it with text. I just know this works. So we'll go, and so now we've added this into, this is all to make sure that all of our data is being stored. We have this is all the columns for that query. We are, again, just going back to over here, we've registered it now to dbint. We're going to update the doc string. I'm actually going to update it right now because I want to go quicker. And then I would never push this without updating the doc strings because documentation. But for the sake of this workshop, we're going to hop right along. So now we have our query ready to go. Now let's build a visualization. So we're just going to go and I'm going to copy this template and I'm going to do the exact same thing that I just did for the queries. And so I know I want to add it to the contributions page. So I'm going to paste the query template. I actually didn't put it in the right spot. I need to put it in the visualizations folder. Here is the visualization template, and I want to rename this issue first response. And now we just go line by line of like variables to change. First one, page. So we're just going to go down and change it to the page of here. So it's contributions. Second one is viz ID, and so it's just a short name for the visualization. So I'm just going to choose issue first response. The GC visualization, which is pretty much, this is a group card. You can change this to anything, but it's just again, just a unique identifier for the visualization card. A lot of this structure just makes it to where you can easily reuse code, which we'll kind of see how that all comes together, which is the reason why we're able to take a lot of the code from the other visualizations. We want to update that title. Title is issue first response. I'm going to do the context of the graph later. Wink, wink. That's just the popover. And so now I want to go over and do the IDs of the Dash components, which if you haven't done some familiarity with Dash or Plotly, if you're wanting to get really in the weeds, there's a lot you can talk to me. There's a couple of different there's a couple different videos I'd recommend watching just to understand the callback structure, which is why it's so interactive. But for the case of our visualization, I know that PR first response, the structure is exactly what we want whenever it comes to the callbacks, because I know that the only input that we want for this visualization is that response number of days. So I can go to the form of the PR first response, and this has all of the structure, it has the about, and everything that we would need to go directly into making the issues first response. So if we go over to issues, instead of the template has a lot of options already in there that you can do date interval, that's one that's common. There's a lot of stuff that's commented out for you to use to make your user inputs for your visualization. So I'm just going to take all of this and take it out. And I just want to remember exactly where I copied from. So the row, I'm just going to do from the form. Yay, brackets. Okay, I'm just going to copy and paste this all over. So now we know that by putting this directly into the form, this is going to make it to where our visualization has the exact same inputs as this one, which is the response number of days and the about graph. So we're good to go. And the IDs are already all handled and unique because we use that page and Viz ID option. And so even though we took this from a different page in Viz ID, we can do it here because we've defined it uniquely for this page. And so we have our response days that is specifically for issues. And we didn't really need to put any thought into it for the visualization. Also, for more notes, a lot of the different stuff that I'm talking about that's not on here, this is just like a specific, like you need to remember to change these things, but there's an entire document of every single thing you need to do if you're creating a visualization straight from scratch, and I'm not here just monotonely talking about it. So now we can go and we need to change the name of the visualization graph. So same thing right here. We're going to go and do issues first, response, and I got a little bit distracted with the IDs, the dash IDs. We now know that it's the response days, and those are going to go directly into a callback. And so, again, these are some of the things that if you want to start making your own visualizations more specifically, that'd be good to spend the 30 minutes kind of going through the dash structure, but you're able to follow it just with some of the inputs to know that we're doing the callback for our visualization. These are commented out because this is stuff that we don't need. And this one was like the pre-baked option, but that's not what we have. We know that because of the structure up here, that we're just going to take the ID up above and do the, right here. Here. And then I'm actually going to comment out this bot switch. We in 8-Knot, and you could make this without it, but I know that this is going to make it to where any response from a bot is not automatically considered. By now we can look at this definition. We have our repo list. We want to have the num days here. And then the bot filter. And so we have, when we comment out here, you can see uncomment if the bot filter applies. And in this case it does. So we can go and do this, and so actually it's called bot switch. The bot switch is on. So we have that, we have this set up. Let's go back up to our list, the comments with the date times and the sort by. I'll come back to all of this, and then let's just hop over to doing the queries. A lot of times whenever I'm going through this, you don't have to do it in order. I just delete every time I actually do the thing that it says to me to do. So we need to go and import the queries. So we know our query name is issue response query. And we want to import issue response query as issue response query. Cool. And so we'll go down here, and we want to change this. This is pretty much going to our caching system and tells us, please get us the query for the specific repositories that have been requested. And so now we have it set up to where it's going to get the data. We're going to make sure that this is just a preventative error handling. And now let's do that process data stuff that we had already done in our notebook. And we have the num days because that's the input in for the days. So for our process data, you can kind of read through all of this whenever we're not walking through, but it kind of tells you how to go and look at if any other visualizations have a similar process. We know that it does. Oh no, please reopen. Oh. Please. I will be sad. That was really tragic. Let's see. Yes. I was on a really good, good track. I would have loved to have been slower through this, but, oh, come on. I'm just gonna reopen my notebook environment really quickly. Actually, you know what, I'm not, this is OpenShift AI, internal team. This is, remember I was saying that I put myself in a playpen? This is, I make other people build the playpen. This is just the notebook that we were looking at before. And so I'm just gonna go and copy and paste what we got from the process data. And we're gonna put that, shocker, right in process data. And we know we need to do the num response, the get, let's see what, it's mad because I didn't tab, yeah. That, we want num days. And so we need to get that get open response thing we were looking at earlier. Come on. So I'm just gonna paste this over here, put it in. And so now we have all the data pre-processing, and now I wanna go and create the figure, which imports that num days as well. Look at here. And we're gonna go and take the create figure data and put it directly in the create figure section. And actually, that's from, I'm gonna have to re-edit this because this is not the notebook that we just did. Let me just generalize this back down to data frame. Big shocker, when I started going into all the deep visualization code, people started leaving quick. So yeah, we just took pretty much what I was just doing pretty quick. The movie magic is just copying and pasting from that notebook. And so now I know all the queries are done, so I can delete that. I know that we'll do comments and things hypothetically later. But we know the sort by, the date, time, all of that has been handled by the stuff that we did in the notebook. And so now we just need to go through we just need to import the visualization into the page, which is all directly in that note from visualizations.issue first response, import GC issues first response. And then we'll just make a new column. This is just the putting that visualization on the page like we were showing. Issue response. GC issue first response. Let's save that. And then that's all done. Cool. We've done everything that we need to do based off of the template. Obviously, I would want to clean everything up, but let's see if on the first run it works. That would be surprising. So, just built it the same way that we would before. I don't want to. We don't have time to. It'll work without the, I've already run it with. And would you look at that? Issue first response is there. And let's see, okay.
Boo. No, it's actually not. It's from the, I know what this is from. It's from the, I've done this every single time I've demoed it, is that the results is in DF responses, and so I just need to make sure that that's the thing that we get from our process data function. And let's try this one more time. Oh yeah, so that's just the pipenv thing that like, so pretty much if you have it's not a file, or I guess it's a file, but I don't like pretty much all I do if I'm in an environment is that I make sure that pipenv is installed, and then if you cd into that repository, you just have to run pipenv install, and it installs all of the requirements that are set for that repository. Oh, the requirements is like in a requirement txt, I would assume.
It's like pipm and pipm.lock.
Pipfile.lock?
Pip file, yeah.
Yeah, okay. So that I think we need to add to the.
Yeah, because that was a point that we were kind of like, I didn't really know with the notebook side of things of how much we wanted to set up an environment and all the different stuff. But would you look at that? We got a little working visualization. Everything's good. We can see, obviously, whenever you go and plug something back in, there's going to be little things that you're going to want to tweak on. But we have a functioning first response visualization. I know we went through that pretty fast. Good things to note whenever we try to do this again, of trying to figure out how to simplify some stuff. But that is like an end-to-end process of making a visualization, from concept to looking at the documents that are available, looking at the code of things that are already existing in 8.0, getting it working in a notebook, and then getting that based off of the templates, working interactively in a dashboard environment. So that's that. People have questions, comments? I just talked a lot for a long time, so yeah, for sure. Yeah, please like tell us, like reach out to us, let us know, open issues. Like y'all are honestly like such a good litmus test for us, because you should be able to do this with our if you're not able to follow the documentation and create a new visualization, that means that there's stuff that we need to add. So that means mutually productive stuff. So yeah.
Yeah, any questions?
Questions, comments? Yeah, I know there's a lot of information. It was a lot of information for 3 hours. I know, we're going to be doing a similar workshop at another event. And so if there's any things that you'd be like, maybe next time don't spend as much time there, this is the stuff that needs more time, great feedback, always welcome. So yeah, I think that's all we got. Thanks for everyone staying till the end. Yeah.
Thanks for joining us.
Thanks. It's Open Source Summit North America. It's one of the events run by the Linux Foundation. Yeah. Yeah, the Jupyter Notebook part is hard.
We got to get rid of pip.
What? We actually had a pretty good, I would say, how many people were at the beginning? 10 to 15?
Yeah.
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 Until it got to like the dense live coding, I'd say about 10 people were here. Okay. What about it? Like has anything developed? I've been fighting Sean for days to get slides for this, so I haven't even gotten there. No, nothing has, I brought it up to Dawn, and pretty much there's nothing has changed since we have talked, but I'm pretty much still in the, like, I want to try to figure out a solution that works for everyone, and so whoever, I haven't heard anything different. I was originally told that we were going to, that Sean was going to try to make a meeting with, like, me and Georg and stuff for this week, but that never happened. I don't really. Are they here? No. Or Paturgia, I don't know. I know Sean's not here.
No information on that. Thanks, guys.
Yeah, thanks.
Appreciate it. Hope that was valuable.
Yeah, we'll be around the Red Hat booth all weekend. So if you're trying to stop by, have other questions, want to like work on it more, some of the stuff more one-on-one, yeah, just let us know. Open.
Yar.
No, but it's not gonna. It's like it'd be useful for people, but I think it's also like a good. I think it's a good like if you don't care, even if you don't care about open source or any of this stuff, of like this code base is so much lighter than a lot of other stuff. If you're just trying for the first time, like how do I get something running, and then like how do I contribute to something where I only need to understand this portion of the code instead of an entire set, and making a little vision and want to learn about data. Like if you're trying to learn about data science in general, this is a good entry point. I've actually been working. Yes, it is. And yeah, and it was like I came up with the concept of this project, and then the structure of everything. I came up with the concept when I was a senior in college, and then came up with the structure of being like, I want, and this is also strategic, but it's true. I was like, I don't want to learn anything more about software engineering than I do right now because I want to be the data science persona. That if I'm the person that I just need to understand Python, Dash, plot, like the graphing, if like I just have that knowledge base, am I able to build visualizations in this? And so that's the idea of being able for then somebody else who can come in who's just a data scientist, maybe not know anything about community or know anything about the software engineering, can come in and contribute, or come in and just like learn how to use Dash and learn how to do data visualizations and all that stuff. So I do have some friends that I'm like who are transitioning into data science. I'm like, hey, just come and contribute a visualization, so then you have something to show on like job interviews of being like, I've contributed and I've done this whole data visualization platform end to end. You can make anything sound crazy if you want to.
That's really where I'm stuck. Is what I'm trying to get from this whole expo.
Yeah, if you're trying to go into data science, like definitely come talk. I'll be at the booth, but I do tomorrow. Yeah, today was just like a workshop day, and then the full conference kind of starts up. Like I was thinking, have you ever been to this conference before?
Yeah, but it was I think
Oh,
last year it changed and I didn't.
oh, the first year that I was in LA, I actually like don't think I've ever been to a customer conference before. It was like a low one.
For my ticket and I was like, I don't
No, it was a low one. I was not happy. I was really upset. I really was not having a good time at that conference.
Yep, I do.
Are they gonna be doing the scaling?
They should be able to be doing
I'll
so.
be out scanning people coming in and
Okay.
then just, when you meet your phone, just send out alternate.
Okay, perfect. Thank you.
we got one of these,
Uh-huh.
which is fine. Oh, no, you have that.
Yeah. Yep, that's fine.
And this is live too, so don't touch the plug-in for sound on the computer.
Okay. Need it?
Yeah, or turn it down. Is there a soundboard in there?
Yeah, there is, but I'll be fine. I can also, my voice carries.
No, I'm saying this thing.
Oh.
See how you touch it?
Mm-hmm.
If you don't need it,
That's okay. We can probably just leave it. I
you can
won't touch
leave
it.
Just be careful.
Yeah.
Otherwise, it'll crackle on your own days.
Power cable.
Silent. So I walked over there. The machines were not working, so I couldn't get a drink out.
Oh. Did you go to Starbucks then? There's like Starbucks right,
But they don't have any kind of,
like a water bottle.
yeah, but they don't have anything else. They don't have, I'm not a coffee drinker, so it's never good. So are you going to be following us as we go through this? What's one of the requirements are you expect to have internet access, right?
Yep, internet access and a Chromium-based web browser. Yes.
They can follow along or they can watch.
Mozilla Firefox is fine. Should work.
How's the Wi-Fi here? Is it pretty solid? I've been using my hotspot and it's kind of slow right now. No comment? That's fine. It's all right. It works.
So for those of you guys watching in, computers, if you're going to participate, computers up, Chrome-based browser, that's about all you need. You're ready to go.
Yep. Chromium based.
Give it a try. Tell us how it works. Maybe it will, maybe it won't. We don't know.
It's yeah, you should be fine with Firefox.
We've heard of both, so. Oh, look, Mozilla Firefox.
8 more minutes.
Now, usually the people that work at it come up and they grab these and they'll stand over there and tell us 10, 5, or 1.
Until we're done?
Yeah.
Okay.
At the end, they'll tell us when there's 10 minutes. They're automatic.
No, I'm just introduction. Like next slide. Yeah.
I don't know if they were asking for it.
Yeah, no.
Heather didn't say anything. Heather's usually on top of her game.
Yeah, she used my Slack photo, I think. What happened? Yeah.
Welcome to the guys that just came in, guys and gals. If you are going to participate, all you need to have is your laptop up, wireless working, and a browser. Chrome, Base, or Firefox. So everything we will be doing today will be displayed on the screen, as well as you can follow right along on your laptop. So if you can't see very well or you're in a bad place, don't worry. Everything will be on your computer. Even if you just want to watch and you're not participating, you can still watch it on the computer, but we'll have it here on the screen. So I think Logan went off. Building and set up the booth.
Is the other building?
I don't think Heather showed up.
Yeah, I don't think Heather's here.
She's down in Huntington Beach. She's not in that far.
I think she moved.
She's at Huntington Beach.
Oh.
She was up in Bay Area,
Hmm.
San Jose. And now she's living down here in Huntington Beach. Huntington Beach, Long Beach.
One of them.
One of the beaches.
So why don't we have a booth?
Okay, just a couple minutes before we start, and I'm going to ask a question, and I hate to have to raise my hand. I hate to say sorry before I even ask, but real quick. Kubernetes people, been there, done that, wrote the book, got a t-shirt, ready to go. And so everybody else, just been perusing them all, haven't really bought the shirt yet, but heard about Kubernetes, right? The rest of it. Sorry? Well, that means you're a little farther along. You kind of, you've heard about it, you know what it is good for, you know what it does, and we're going to show you how easy it is today. Absolutely. Well, we're going to show you how easy it is to do, and if you want to run through the same thing again one day, we do this online every couple of weeks. We're here today doing it in person with everybody, but we do this online all the time. So these are called rancher rodeos. And you can join the rodeo at any time. So how long did you say we have? 3.5 hours?
Yeah. All right, seeing as that it's officially time to start, I'm gonna slowly let more people trickle in, but I'll start by giving both Brian and I an introduction. So let's get started. My name is Austin Iveson. I'm a solution architect at SUSE. This is Brian Six, my contemporary. He'll be walking around helping you guys out in case there's any kind of like troubleshooting issues, because we do run into those every now and then. And so kind of just talk about the agenda for today, the objectives we have. So this is going to be surrounding kind of like the basic concepts of containers and therefore Kubernetes orchestration, which is container orchestration. So we'll start off by going over some basics, cover some architecture, both within Kubernetes concepts, and then, you know, once I'm done giving you guys a nice little slide show, we will actually get our hands dirty. We have some instances that we'll be spinning up for you in the cloud, and you can actually hop in and deploy your own Kubernetes cluster, as well as our Rancher tool and so forth. So just to give you some forewarning, this is not intended by any means to be something that you use in production. The environments we're spinning up are singular nodes, so there is no resiliency, there's no highly available aspects. Don't copy and paste this exact situation essentially and take it to like a production environment. You will have a bad time. But it is a really fun lab environment. So by all means, like if you follow along with the scenario and then take those steps and put them into your own little home lab, you can absolutely do that. I do that myself, obviously. So just some prerequisites. Up-to-date browser. Make sure you're using either Chrome-based or Mozilla Firefox. Safari, for instance, has issues, so don't do that. All right. Any questions? Start off. Cool.
Oh, question.
Oh. Yeah, how you would set that. That is a conversation. I can kind of like get into that. There will be more like high-level conversation surrounding the architecture for something that would be within production, just within like the slides and then with what I show you. It's actually not many more steps. So yeah, and we'll touch on that. So thanks. Okay, so containers are great. They're fantastic. They allow for an immutable system that can be deployable anywhere. It's consistent. Think of it as like a file system with a read-only and a write-only layer. So because of the simplicity of it all, you actually just have your application's code and you have dependencies. You package that into what we call a container image. And so again, you're going to have a container, and then the container runtime takes that read-only file layer and puts a read-write layer on top of it. And so therefore, you can deploy it anywhere and it's going to be consistent. So to what building an image, a container image, looks like, we'll start off with this. So in the very first page, or very first spot, this is a Docker file. We are referencing where we're going to get this container image from, so the base image. The latest version is going to be the Ubuntu container image. We can add labels, so maintainer equals this, and then we can add some run commands, at git update, etc. We're going to install Apache on there, and we're going to set things like the working directory and so forth. So what this essentially does, down at the bottom, we're exposing a web server to serve on port 80. So that's what this container does from the Git, and that's what it will do the moment you deploy it. So how do we run containers? A container image, right, is going to be referenced, and these little arrows would reference such things as like a Docker run. And when you do Docker run, it takes that container image and deploys containers. So the Docker run command is obviously going to take that image, runs the container. Again, the images are immutable, so a single source of truth, and so forth. So again, they're portable. It allows for the build application of and all the dependencies to be deployed once and anywhere. Launching a new container of the same image guarantees a clean runtime environment when you start a container, and it will be the same state in each of those containers. So, perfect. This is kind of the architecture of what it looks like to have some containerized applications. We're going to compare ourselves to some traditional workloads there on the left, your left, my right. And then on the right side, we have the containerized applications. So what we've done, or well, what containers have done, they've essentially made the host operating system a layer just like the hypervisors. So, we've got the infrastructure that stays the same, but instead of having guest operating systems, we actually just make one singular operating system. We deploy a container runtime. This example is going to be Docker. There's other things like Containerd, etc. And that actually goes ahead and directs the building of those containers. So we need a place to store container images. So a common registry is going to be Docker Hub. So these container images are stored within here, and this is when you can start running commands to either pull an image down, push an image into the registry, and then if you run an image and it hasn't been pulled already, it will do that automatically. So yeah, there's some other tools that you can apply to container registries, such as like Artifactory, Quay, some options, or sorry, those are repositories themselves. You can deploy such tools as like Trivy, etc. inside of your container registries to provide some scanning, but this is just some examples of what container registries look like.
Hey, Austin, real quick, do we have a slide on microservices at all?
We don't.
So go back to the virtual machine comparison. So there was a decision that was made. A bunch of guys sat around developing software one day and said, there has to be a better way to do it. And as a developer myself, I wish this would have been something I thought of years ago, because it would have started this whole thing a long time ago. But the idea behind a microservice was, instead of building an application the way we had always done, where you would build it on your think of Word, Microsoft Word, for example. It's one big giant program. The thesaurus, the spell checker, the thing that tracks how many words and counts them together and does checks your English syntax and all that. So Word is this big giant thing. Well, somebody sat down, or a group of people sat down and said, you know what, there's got to be a better way. Because when one of those things blows up, the entire thing shuts down and it dies. So how can we do this better? So they came up with this idea of microservices. Let's make Word not just one program, but 30. Let's break it up into a whole bunch of really teeny pieces. And we'll call them microservices. Makes sense. And instead of course, there's a downside to this. Instead of you launching one program called Word, you have to launch 37 of them to make Word work. And one of them happens to be the user interface to Word. But they're all different. And they will all talk to each other over an IP connection. They do not have this in-memory capability that we would normally have with an application, where I can talk to things that were compiled in memory together. Like all of us in this room could be a single program together, but we talk to each other over an IP connection. And this is important, because a whole different world from just loading it up on top of an operating system as a singular thing. Imagine over here that all of those said app A. Forget app B, C, D, and E. All of those were responsible to make app A work. But the beauty in having them all separated is that they all have their own life cycle. They do not all go from version 4 to version 5 at the same time. So the UI could go to version 4, 5, 6, 7, 8, 9, 10, but the spell checker doesn't have to. There may not be much new to add to the spell checker. Or the thesaurus can go through a bunch of revs. None of it is relying on everybody. And you build in the notion that everybody else has died. If I can't talk to my other counterparts, don't just blow up and blue screen and leave me hanging. Give me a message. Can't talk to the spell checker. Don't do that right now. Can't get to the thesaurus. Don't do that right now. Oh, the thesaurus is back online. Yay, everybody's happy. So we're microservice based. We're IP based. So we're all talking to each other over IP. And there's some resiliency in it. The notion that I can just restart the spell checker if it stops. And nobody else has to know. So I can get upgrades faster As a developer, I can push things out to my customers way faster. If I'm a developer, I can just develop my own little piece here. I don't have to worry about what everybody else is doing. Because all you're doing is you're coming to me with a request over IP. Now, IP becomes important. And managing now, think of it, if all of us were part of this program that made this application work, someone has to orchestrate for everybody to start, to monitor everybody's IP address. Are you alive? Are you working? And if you've not, restart you. So there are some challenges, because as an administrator of the IT department, I now have to worry about all of you instead of just the one singular word.exe that I used to have before. So containers got really popular. Microservices got really popular. And therefore, they spun into this notion of a container because now I'm going to take the application, a little bit of the operating system that's needed to run that part of the application, and I'm going to build a little bubble around it and say, here is your container. Austin was just telling you, it can run everywhere, wherever a container runtime exists. So wherever there's a container runtime, I can plop this thing down and it'll run. It'll spin up and it has all the things it needs. Each one of these can have its own version of, PHP or Python. Every one of us can have our own versions of what we need because this is how we built. Maybe I'm a Java programmer and maybe someone else is different. Someone else uses Python or PHP. Build it your way. Create this container that has everything in it to make it run, and then set it free. And off it goes. And it can run anywhere I've got a container runtime. And the term container runtime is very important. We'll talk about what that means as we go through this. But this is sort of this idea of why we're doing this at all. Because it's a better way to program. I can develop and get things out faster. Everybody's revving at their own speed. We're not waiting on everybody else. Don't have to. Okay.
Well said. So yeah, exactly. And so if you have a couple of those containers, it's really easy to manage. But once you start having a whole bunch of these, essentially microservices is what Brian was referencing, it becomes quite an issue. And so back in 2015, a team at Google wanted to address this. And they, there was a lot of competition out there. I think Docker Swarm was also a container orchestration tool. But Kubernetes became the de facto standard for container orchestration. It's a powerful open source tool, it's extensible, and it allows us to manage all of those workloads. So it's declarative syntax, so you state in the code, I want these amount of replicas to be running, and Kubernetes actually takes care of the automation of that and checks through certain controllers whether or not these deployments of containers are working. And we can actually go through that because Kubernetes, everything is a resource. One thing that I like to reference is it is all API driven. So, CRUD is essentially built into Kubernetes. So create, retrieve, update, delete those resources, etc. And so now we can kind of talk about what Kubernetes looks like from an architecture standpoint. The smallest deployable unit of Kubernetes is a pod. So this is going to be where those said containers exist now. So we've gone up a layer, right? We now have containers, and then on top of that, inside of Kubernetes, we have pods. Pods will either have a singular container running, maybe another container called like a sidecar, etc. And this is going to be where your applications live. They each have a unique IP address, so that's something to note, and we can show you what that looks like here in a moment.
Quick. So why might you think it'd be interesting to have a pod that has multiple containers in it?
You can simplify how they communicate with each other and how they're addressed as a group.
So interesting answer. Yeah. So to simplify the communication, everybody's should be going over IP, but let me just. He's got an answer real quick. Yours? Yep. So sometimes there are these, they have a name for them. Yeah, the init containers. The init containers that spin up, that sort of prep things for you. The other notion is maybe these two things should always go together. Yeah. So there's a couple different reasons why they may need to be together. So the idea would be we have this little microservice application
that we put into the container. The container is sort of the operating system, the base operating system, and everything that makes it work. And now we've added the pod layer. And the pod layer is very Kubernetes speak. That's a Kubernetes term. But it encompasses a single or multiple containers and provides, some structure to it. And as he was saying, very declarative. So if I am building the software, if I'm deploying the software, I can declare, because it's declarative, I want 37 copies of the UI to be available, because I think there's going to be a lot of people using it. Right? Nothing possible in the previous world of deploying applications. You can never say I want 35 versions of the same interface running, but nothing else, just the UI. You can't do that. It's all part of one thing. But with this, I can say I want 35 of the UI running, and I want 27 of our example earlier of the thesaurus running, and 18 spell checkers, because that seems to scale with what we're building. And you can do all kinds of cool things. So it's declarative. You tell it, here's how I want everything to look. You go do it. And you keep that up. You maintain that. You monitor the failures and you maintain the numbers that I give you. Kind of an interesting approach, but it's great from an administrator standpoint, because I just say, here it is, let Kubernetes take care of making sure the environment matches what I tell it.
Yeah, and to kind of like segue into that, so for instance, the nomenclature surrounding Kubernetes deployments is essentially going to be pods. It's an abstraction on top of pods, so it takes a group of them and it monitors them through the deployment controller of the replicas, and I can actually show you what that looks like via code. So this is, on the left here, we have yet another manifest language, YAML. I'm sure some of you may have heard of it, and we define what this deployment is going to look like. So it has deployment as the kind, it has the replicas, so it's going to have 3 of those running, and then down there in the spec and containers, if you can't see that in the back, it says spec containers, and you actually define the container's image. So this is going to be an Nginx deployment, and it's going to be versioned at 1.7.9, and et cetera. And so the deployment is monitored by the Kubernetes API, and it makes sure that it has all of those pods up and ready. So this is, a representation of what those pods are doing. The API is monitoring it, sending information to the controller and saying, oh no, one of your containers crashed. Let's just kill it and bring it back up automatically. And so then it will do that for you. And so then it's making sure that it's meeting that resiliency with the 3 replicas and so on. So to talk about more pieces within Kubernetes, we now have services. So these are going to be an abstraction on top of the logical set of pods. So these give addresses to to access pods. There's such things as cluster API for communication within the cluster, the Kubernetes cluster. Node port, which can expose outside traffic to a singular node, so the host. And then we also have like load balancers, can expose services on a cloud provider, and et cetera. So to kind of demonstrate.
So can I just mention something real quick? The cool thing about services, in the previous slide, remember how he kind of killed all the pods and then he just regenerated themselves? Well, if I do that, what happens to all of the IP addresses that were assigned? What happened to all the connections? What happened to all the things that knew about the old pods? How do they find them? So they came up with this idea called a service. Well, we'll just create these things called services, and here's what's really cool. They're not really objects. They're just these things we'll make up in our head. We'll call them services, and we'll maintain a list of what's supposed to be out there and who's trying to talk to it, and then it will be sort of that interface between what you need to know about and how to talk to it and what's really running. And so we'll abstract a lot of this away. In fact, Kubernetes abstracts a whole host of things away from you so you don't have to worry about it. But services are very cool because they keep you from having to know when there's a failure, well, where did it go? What's its new name? What's it called? On what host did it run on? We haven't even talked about the fact that this thing could scale to, who knows how many number of hosts that are running. Could be 5, 10, 100. Where did it go when it respawned itself? So the services keep track of all that.
Yep, And to kind of give you a visual representation, we have a service here that is going to be referencing a deployment, and it's going to be those deployments. Again, each of those pods have unique IP addresses, and this load balancer makes sure that traffic gets to those endpoints. But the load balancer is monitoring that, but what if one of these pods die again? They're not going to come up with the exact same IP address, right? That endpoint changes. And as you can see here, it takes care of that for you automatically. So now you have a new pod up with a new IP address, but it's still getting load balanced perfectly, and there's no manual configuration that you have to do. So to talk about another one, we need to now allow traffic inside of a Kubernetes cluster. And so we have a service called ingresses. This is going to be exposing your cluster to outside traffic via HTTP and HTTPS. It gives an external reachable URL, which we can send our traffic to. So there's rules that we can define within the ingress, so we can show you on this next page what that looks like.
Can you go back to the previous one more slide? There. Notice the bottom. What IP addresses are we looking at? 10 dot somethings, 10.23s and 10.24s are the things you see. Yeah, they're not routable to anybody. In fact, when you build a Kubernetes cluster in your data center, it is a data center in and of itself inside of your data center. Nobody in your infrastructure can route into it. There are no routes into Kubernetes. We're abstracting all the networking away. So there's no way for you to get into it. So how am I going to get to the UI? If I'm building this fictional word processor called Word inside of this, how do I get to the interface to do something to it if I can't see it? We need this. We need services to define it, and then we need to have this ingress controller that we're talking about here and rules that say, oh, you want to get inside of this cluster and see something, point to it. Well, let me build an interface for you. And they called it an ingress.
Yep, and that is exactly what this is. So as you can see here, we have a user that is going to have traffic going from two sections of this website, and this ingress is defining over here what path that's going to. So /foo/bar, and this is going to then take that ingress and say there's two paths that we want to direct that traffic to, and we want to direct one path, the /foo, to service A. And service A is going to load balance that and then send that to the pods, somewhere down here. And then the /bar, same concept, but now it's going to service B. So again, abstracting away the network, and just this this line is demarcating the Kubernetes boundary. So this is all external traffic coming into the ingress and so forth. So let's just continue on. There's a lot of resources out there. Again, Kubernetes, everything is a resource. You have config maps which store non-confidential data in a key value pair. We have secrets that are base 64 encoded, TSL certs, bootstrap tokens, etc. Persistence volumes, so storage in the cluster that has been provisioned by an admin. You can actually do that just manually, or you can do it dynamically through storage class, such as Longhorn, which is a tool that we have at Rancher for that. And then horizontal pod scalers, and that allows you to set, via some metrics, like if pods are reaching a certain amount of CPU, it'll automatically scale out more pods, distribute the traffic, etc. So, and then the last, and cron jobs as well, so in case you just want something that runs once to completion. So to talk about the architecture here, again, so because this is all done via API calls, it's speaking through the API, we're using kubectl, this command line tool, to actually speak to the control plane. And as we can see here, the control plane houses things like the API server, a scheduler which binds pods to nodes, the controller manager, which takes care of running controllers for deployments, replication controllers, services, deployments, etc. And then just off here at the left, we have the etcd. Again, it's storing in a key value pair. So the etcd is leader-based distributed system, and so forth. And oops, I wanted to go over here, not do that. And so on the right, furthest right, we actually have, it doesn't say it, but they're defined as nodes here, but they're worker nodes. And this is actually where you end up deploying your workloads, not just the ones that are within Kubernetes, like the control plane. and so forth.
Did you talk about CRDs at all?
A little bit, yeah. Custom resource definitions. I didn't mention them yet, but we will. Yeah, yeah. So yeah, and the worker node has a kubelet. That kubelet is serving information to the Kube API server, notifying it like, hey, this is what's going on in the worker nodes.
The etcd that you're seeing there, by the way, it knows about all the resources that are running in the on the worker nodes and all the resources that exist in Kubernetes, and it knows everything. And it is, as he mentioned, as Austin mentioned, it's a unique database that was built to do this. It was called a key value pair. It's real simple, very fast lookup. But it just stores a ton of information, and it is replicated when you have multiple control plane nodes. In our picture, we only have one.
Our friend here has a question.
Question?
Yes, it is unclear to me. So each node, is that made up of a collection of services?
It's a node. Consider it that's a virtual machine or physical bare metal. That's a virtual machine, physical bare metal, virtual machine, physical or bare metal, virtual machine or physical bare metal. Those are all individual real servers doing something. They have an operating system loaded on them, and then they run Kubernetes. So it's a really slim format, if you will, or it's a very slim layer. You have a smallest operating system. I mean, I don't even need much from your operating system at all. I just want you to run. In fact, we have something called SCaLE Micro at SUSE that is this very small, hardly takes up any room. You can put it in your back pocket, that kind of small. We don't need anything from the operating system itself. All that it runs is the container runtime that Kubernetes is.
And on the node is where you put the pods, and inside the pods is where you put the deployments, which have the containers, right?
Yeah.
Deployments are pods, and then pods have containers, which, yes.
Yeah.
You were like right.
And so you tell Kubernetes, you tell one of the control plane guys, here's my deployment manifest that you saw earlier. And then it reads through that and says, okay, I know what you want me to do. I know how many copies of things you want. And then I'll go grab them all. And when he pointed to something called Nginx earlier, and he said, I want an image in a certain version, by default, we know where to go. There's these things called registries that everybody piles their images into, and then we can just pull from them. Was there a question in the far back? No, okay. So yes.
The YAML file defines the deployments, but it doesn't define the nodes. That's part
No.
of the
Correct. So the question was the YAML file or the statement defines the deployment, does not define the nodes themselves, and that is absolutely correct. Those are specific things that are built outside of this deployment. Yes. Yeah.
If you do things in the cloud, we can actually, like through some tools we have, you can actually just automatically spin up more. Yeah. So, yeah, and we'll continue. So setting up Kubernetes takes a lot. There is a fun little project, Kubernetes the hard way on GitHub. You can go through that and manually set up a Kubernetes cluster or, essentially like distribution in a sense. But just like Linux, you don't usually compile Linux from scratch unless you're like a bit of a masochist. And there are distributions out there. So we at SUSE actually we acquired Rancher back in 2020, and with that came a couple of things. Some tools such as Rancher itself, and then also the Rancher Kubernetes Engine 2 or Rancher Gov. This is a distribution of Kubernetes. It is going to be more security-based, so it meets those FIPS compliance, CIS benchmarks, and it uses Containerd as a runtime. Back in the day, Docker was actually the runtime, but that was deprecated and removed from the upstream Kubernetes world, and so now there's things like Containerd and some other container runtimes out there. But it's meeting that standard in the cloud-native world. And then we also have kind of the princess in my mind is K3s. So K3s was developed as supposed to be like a lightweight. It's actually just a visual joke because K8s is the abbreviation for Kubernetes. Slice that in half, and it's K3s. So it's extremely small. You can deploy it on edge, IoT, etc. Similar to RKE2 with Containerd. but this is also comes with MySQLite. You can obviously use other, so you can use Postgres, etcd, MySQL, etc. And it is, again, optimized for like ARM deployments as well. So, you know, K3s isn't a replacement. Sorry, it's a distribution of Kubernetes. Yes, sorry. There's multiple out there. GKE for, you know, Google, RKE too, like I just said, et cetera, and, you know, a lot of major companies.
Just like there's different Linux distributions.
Yeah.
There's SUSE, there's Red Hat, there's Ubuntu,
Yep.
Rocky, Alma. There's a whole bunch of people that build a Kubernetes distribution that builds the infrastructure that supports these containers as they run.
Cool. And so, you know, like that previous picture where it's like, how do you manage a couple containers? Well, you start building environments in, you know, production environments, and you start having clusters where there's different teams, there's different products in different clusters. You need to be able to, you know, give access to certain people, and how do you end up managing that? And that's where Rancher Labs decided to create their tool. And so, you know, managing the Kubernetes ecosystem also ends up being really difficult because it's quite large. This is just, yeah, database. This is all just databases. So if you look at the cloud native landscape, it's massive. You have everything from container runtimes, registries, networking, service meshes, etc. So, oops, we went ahead and built out kind of something that we can bring up and have things going like day 2 operations pretty quick. So with Kubernetes, down here we have, again, these are the distributions that we support. You know, anything that's in the cloud native, you can work with Rancher, you can work with us. You can deploy on top of any of your Linux distributions, such as like RHEL, Ubuntu, Oracle, these ones right here. And then we deploy Rancher on top of a Kubernetes cluster. So with that comes tools that we manage and build for you, both with Prometheus, Grafana, Istio for service mesh. We have a Terraform operator, and then we obviously have our Longhorn storage, which I mentioned earlier. So that's going to be block storage that is going to be built into your Kubernetes cluster. So now I can, you know, be done with slides, and we can actually get into.
And real quick, before we go back to the CNCF slide. So this notion of CNCF, the Cloud Native Compute Foundation, if you think about where all this originated when Google built this, it was for building out their cloud services. Think about every time you open up your browser and type in a search phrase. It spawns off a container that performs your search, and then when you're done, goes away. So containers are expected to exist for moments in time and not any longer. There could be some that are persistent. We talked about stateful sets, or at least we listed those earlier. They're kind of an advanced idea, but the containers are running. This landscape, these are all the people that are currently building little projects that all contribute to this notion of a cloud native world that run in this Kubernetes landscape that provide different kinds of things. And you saw the one screen he had just was databases. But I don't know, there's 200 or some here. And they all do a whole bunch of little things. So there is a huge momentum, support. You know, a lot of people are behind this effort. This is not some little fledgling thing, Kubernetes. It's got some momentum going. And these are all the players that are playing in the space. And these are the ones that we would say comply with the standards. As always, I can build something and then everybody takes some of it and does their own thing. So the CNCF, so you look for things that are CNCF certified. All of these guys are expected to run in the same place, execute at the same time, live together nicely, defines the space for everybody to live in and work successfully. So you'll see cloud native or CNCF. You'll hear these kinds of things as we go. A lot of people doing a lot of good things here.
Yep. Cool. And so.
Can we go back to the previous slide? So here on the bottom, the black thing here, and then the gray thing there. This is where I can run distribution.
So yeah. So
This is the distribution layer.
yeah, that's the distribution layer. That bottom layer is going to be your host operating system, so your OS layer. And then what happens on top of that is we actually deploy Rancher as a Helm chart. It is just, and it also is going to then, it'll be a better visual representation.
Yeah, we kind of skipped.
Yep.
Yeah. So this is the operating system layer. This represents those nodes we looked at. This is the Kubernetes layer. And notice some of the guys in the middle, those are things that you don't even have to build. They just exist in the cloud providers, and you can just go pay to use their services. You don't have to build any of the lower stuff. And what's interesting is this stuff up here that Austin was talking about. Remember earlier we talked about a single word exe turned into a whole bunch of microservices, and now there's 30 of them? We've got to manage that. Well, what happens when you have, so you build a Kubernetes cluster to manage that. What happens when you have 50 Kubernetes clusters? I got to manage that, right? It just keeps going up and up and up. And so this layer here is where we get into, well, what happens when I've got more than one Kubernetes layer? What if I've got this guy running and a bunch of those running and this running over here, and all of a sudden I've got 50. Give me an interface. Show me where I can see them all. Help me to deploy them. Help me to delete them when I want them to go away. Give me some ability here, because you're killing me with all these Kubernetes clusters you keep launching. And so that's what we do with this layer.
Yep. And now we can do I'm going to give you guys some time to, can you guys see the instructions up here? So this is going to be Hobby Farm, and this is where we're going to have some instances up and running for you guys now. So if you go to learn.na, maybe I can zoom in and that will make things better. I can't. That was foolhardy. So yeah, learn.na.hobbyfarm.io, and what we're going to do is then you register with an email and a password, and then you enter in this access code. You enter this access code over here. So you probably need to refresh your browser, but I'll give you guys some time to do that. Maybe walk around and see if anyone needs help. But sorry that this, let's see if I can.
So
learn.hobbyfarm.io. If you ever want to do another rodeo, yes. If you don't, then no. I will say, I don't know if any of you have done a rodeo before. We don't have a way to retrieve passwords. So, yeah. If you want to end up doing a rodeo, we offer rodeos for other products as well. Definitely memorize the password for that or put it into your password manager. You're going to register at learn.na.hobbyfarm.io. So, okay, yeah. Okay, I'm going to swap my screen real quick. So I want to make sure that everyone went over into, so if you're in the Hobby Farm landing page, in the top right, you should have your email address listed there. Click on that, and then go down to Manage Access Codes, and there you will enter this access code, which is SCaLE lowercase 2024, and then you should see a scenario pop up. And so I will show you what that looks like. Let me just change some things real quick. Did you enter that access code when you registered? Yes, okay, perfect. Just making sure, because sometimes that doesn't get clear. I'm going to change some settings. see if I can get this to mirror.
Well, Austin switches over. Let me just throw something out to you. We talked about these things called Kubernetes resources, deployment, stateful sets, services, ingress controllers, ingresses, the services. There's a whole bunch of things. These are called objects. These are resources. The beauty that they built into this idea of Kubernetes is, well, what happens if we want to come up with a new object later? What if we want to build a new one? So I was asking earlier about CRDs, these custom resource definitions. So you saw the manifest file that we saw earlier that was just the deployment where we kind of declared what the deployment was going to be. Well, now I can just throw at this cluster, guess what? I want a brand new object to be created. Here is its definition. I want everybody to know what it is so that when I start making calls to it and I start asking for things and I start passing information and I reference it, I want everybody to know what this is. So they came up with this idea of a CRD. So this thing is ever expanding. It can have all kinds of things. If you make up in your mind something that you see is missing, go create a CRD, build a whole thing around it, publish it, and then everybody can use it. It will not break anything. So it's meant to be extensible.
Cool. So everyone should see this. If you don't, then there are some steps that we're going to have to take.
So the question is, does anyone not see it?
Yeah, I think do you not see it? Okay, can you go help him, maybe show him
Yeah.
So one thing, you might have to refresh your page. Again, if you can use either Mozilla Firefox or a Chrome-based web browser, but you can manage the access codes here. And then under, so today's access code is SCaLE 2024. So if we all click Start Scenario, we're requesting our virtual machine resources. We have these pre-running. So if you guys wanted to, just make sure you're on this page, and then we can begin scenario. Give you a second to go away from this page onto the next. Cool. So I'll make sure we can get everyone caught up here. Does anyone have any other questions real quick? Or just to give an outline, the agenda, what we're going to be doing here is, again, provisioning a cluster. We're going to be doing that with our distribution, RKE2. Then we put Rancher on top of that. And then once we have Rancher running, we provision more clusters, well, another cluster using Rancher. So, yeah. Perfect. And again, this should be, you guys should be seeing the exact same thing as me. We have an info tab, a cluster 01 tab, and then a Rancher 01 tab. What's going to happen is, let's see, okay, that's good. What's going to happen is as we go along these instructions, we're just going to click on some commands and it's going to start doing the installation on the appropriate VM. But there are some situations, and I'll address it in the future, but there are some situations where we actually manually need to paste something into the terminal. Please make sure that you take pause there and let me instruct you through it, because if we run a couple commands in the wrong spots, it will have an issue. So let's go next. So again, this is not a highly available installation. This is a single node. And so the first thing we're going to do here is actually using a curl command. We're going to click on this right here, and we'll see if we click on the Rancher tab over here, there's going to be a sudo command that we can click on, and that's going to run an installation script that we have for RKE2. Again, this is a Kubernetes distribution. From there, we need to do some configuration.
So we click on the Rancher 01 tab, correct?
Yep, just to see it, yes. It will automatically run inside of your Rancher 01 when you're clicking these. But this is the command that's being ran. If you click on it, and as you can see here, we've got everything situated. So now we need to configure the RK2 cluster. So we're going to make a directory in etc/rancher/rka2. We're going to make a kube config and define what its permissions are. And yep, perfect. And then if we want, sudo systemctl enable and start, and this is actually starting that RKE2 cluster. Just give that a second. You guys will notice, like down here, it's just paused for a brief moment. And is anyone?
So the first command installed Kubernetes on your whatever node that is, the Rancher 01 node. That's all it took to build a Kubernetes server. Now that's one, and we are building a Kubernetes server that's doing all three roles. It's an etcd server, so it's running the database. It's a control plane, so it's monitoring everything, and it's a worker node, so it's doing all three roles. If you were to build this out in a 25 node cluster, you could say, I want 3 etcd nodes, and I want 5 control plane nodes, and I want everybody else to be a worker node. You can break it up that way, but today we've just got one, it's doing everything. So that first command created a Kubernetes distribution or Kubernetes server using our distribution. That's all it took. Yep. One simple command, and you were up and running.
You can access the logs here and see what that actually looks like. It has some wait time, and that's fine. It just takes a second to catch up, but it is up and running. So we're going to go ahead and go next here. So if everyone clicks on next, make sure you're at the top. You're going to.
The journal control thing, do we need to do that?
I did it. I know it's just this log right here. If you look up, it's just saying that it's starting the Kubernetes.
It tells you if it's running. So it's sort of like a troubleshooting test.
Yep.
Just validating along the way that we're working.
Yep. And so now we actually need to install the kubectl, which is going to be the command line tool that we use to monitor Kubernetes clusters at the terminal level. So if we run this curl command, it will do all of that for us. Oh crap. Okay, now I actually need to get out of the. That's fair. Okay, so if you ran the journal command, make sure that you get out of it, because I didn't. Now let's run that command, and boom, we've got kubectl. We have it in user.local.bin/bin, etc. And so to ensure that kubectl can connect for Kubernetes clusters, you actually have to reference that kubeconfig, which we referenced in the previous step in the etc/rancher/config. And so forth.
Yeah,
But
so
now,
one of the keys to the kingdom here is that config file. So when you installed your Kubernetes cluster, that process creates a file, and the file could be under a couple different names, and it doesn't matter what it's called, but its content is very important. That content is how you're going to talk to that Kubernetes cluster, because that Kubernetes cluster has a SSL certificate that is required. It is generated by the Kubernetes build process. Kubernetes itself creates this Kubernetes certificate, uses it for all communication. So everything that communicates inside the cluster is over SSL via this certificate. So we need this guy, or we cannot talk to that cluster. We don't know how to talk to it. We don't have the certificate to do so.
Yep.
So this config file, for us, we initially put it under /etc/rancher RKE2 RKE2.yaml. But Kubernetes expects that file to be called config, C-O-N-F-I-G. And if you put that file in your home directory under the .kube directory, which is what one of these steps will do for you, this kubectl command knows by default, whoever's running kubectl, go look under the .kube directory in their home directory, find the config file there, use that to connect to the cluster so that you can look at it and query it and do things.
Exactly. So now that we have that config, we're going to reference it to that .kube directory. And so then we should have the ability to run kubectl commands, because kubectl can see the Kubernetes cluster's configuration. So let's run kubectl get nodes, and we will have the name of the node, it's going to be the internal IP address, it's going to have those roles like Brian referenced earlier. Again, all three, so we've got control plane, etcd, master, and then it shows the version.
Yeah, so this is important because we won't be able to go on further if we don't have this working. Is this not working for anybody? Does anybody not have the kubectl returning?
Is it giving you like a local host 88?
I think it's just that it doesn't, I need to, no, the kubectl isn't there, so.
So if you need to install kubectl, there's this command, the curl, and it should give you this nice little, representation of how much it's been installed. It's a curl command that references the documentation for kubectl.
Yeah, so to do that one. So your cluster's probably working, but we don't have the tool that queries it. So get that, kind of follow from the steps and see where you go. You something over here? Permission denied. Interesting. So that tells me that you're not pointing to the right kubeconfig file. So I would go back and validate the previous step that you clicked on that made the .kube directory and that did the link, that created the soft link for it. Make sure that happened.
Connection refused is the same thing, or?
When you do a connection refused, is that when you ran the kubectl command?
Yeah, or the.
If you can't find the config file, it'll give you all kinds of grief.
Yeah, the config file should be there, but let me make sure that.
Make sure that you ran the ln minus L or S. What do we do? Did we do a soft link? Yeah, we did a soft link.
I went ahead and typed in this command here at the top. If anyone's having issues, we just let's make sure that we have the RK2 service running. So the engine here, V2, should be active. If you do systemctl status RKE2 server, and you would just type that in there. So, just some brief troubleshooting. All right, I'm going to get out of this right here, and I'll have Brian hop around and help any of those who need to spend some time just getting caught up a little. So again, just to kind of backtrack a little, we're going to run kubectl get nodes. Those are those hosts. This is the VM. This is the thing that has a Linux distribution on it. And then we are going to then run kubectl get pods. So if we run kubectl get pods, tac all namespaces, you can actually see all of the pods, therefore containers, that get deployed with our distribution RKE2. So if you ran kubectl get pods, you'll see things such as, again, I mentioned the controller manager, I mentioned the kube API server. These are all, this is cut off, but these are all one for one out of the status and running. Or there'll be 0-1, which these were essentially a job that needed to run to what? Completion. And so we've installed some things here, Canal as the CNI, Core DNS, Ingress Nginx, and a metric server. Those are all things that come with our RKE2 distribution, and so forth. So, again, to reference the actual pod that's running Canal, it's right here with RKE2 Canal. Same thing with the DNS and Ingress controllers. So, yeah. Yes, all of those are running as pods within the cluster, but these are the working pieces of the Kubernetes cluster. And that's why they are in the namespace kube system. We will see some other namespaces here momentarily once we start installing other applications into our Kubernetes cluster. So if we click next, everyone should be on the page where it says install Helm. Helm is a package manager, and what it's going to do is allow you to deploy these YAML files as Helm charts. So just to specify, you saw those YAML files with like the services, deployments, etc., a Helm chart is essentially a lot of those. And then they are just referenced into a file, and you can deploy that Helm chart via that. So first thing we need to do is curl that to make sure that we've got it running, or not got it running, but got Helm versioned in there. So if we do Helm version, so I clicked on this curl command. I'm now going to click on Helm version -- client. It looks like we're good. We've got the right version. And then we can use Helm and list all the namespaces that it may have for Helm charts. So as you can see here, RK2 was actually a Helm chart versioned for these services that we provide with that canal, core DNS, and metric server.
This is where we step outside of the standard, like Kubernetes, what do you call it?
Like architecture or version? Well, Helm was listed on that cloud native. So the question is like Helm essentially like something? Yeah, it's not necessarily part of Rancher. We do utilize it because it's a package manager that allows you to deploy applications inside of CNCF certified clusters. So it's just a tool that is basically become pretty standard because it's a graduated project. It's got a lot of funding. It's maintained by a lot of people. So let me continue. Great question. So now there's some requirements that Rancher needs now. In Rancher, we're going to have our TLS certs self-signed, and so we're going to install a cert manager. So we're going to do that from JetStack, and you can just do this with a Helm command, and we do Helm repo add, and then it says JetStack has been added to your repositories. And so there's going to be a Helm chart in there, and when you do Helm install, it's going to reference that Helm chart, and you can actually use some variables to set versions. You can set the namespace that it gets installed into, and you can define if it doesn't have that namespace created, you can actually do that. So we're just going to list this out. And briefly, Brian had mentioned CRDs, that is custom resource definition files. So that would basically be an application that's outside of the typical like Kubernetes deployment, custom resources. So we're just going to click on Helm install.
Austin, can you ask if anyone else is okay?
Yeah, I'll pause here. Is everyone all nice and caught up? We're just currently installing. Perfect. Awesome, guys. Now we'll just wait for this to start working, and we can actually check the rollout status of our cert manager. So it looks like everything's good here, but I'm just going to use a. Yep. And this is good. Just going to reference the Helm install is referencing cert manager inside of JetStack. Well, it's referencing the name, and then inside of that repo, that JetStack repo, there's cert manager Helm chart. And then you're giving it the namespace, version, and you're creating the namespace if it hasn't already been created, which it hasn't. So if we check the status of the rollout, we can just click kubectl /n cert manager rollout status, and it says cert manager successfully rolled out. Super sick, awesome. Now,
Does everybody know what Helm does? Did you describe what Helm is?
Yeah, it's a reference.
Okay.
Like it's a package manager, and the next thing that we do here is we're actually going to start, we can also check the status of, I believe, the webhook. Yep, that's successfully rolled out. So we're good to go. We've got the cert manager webhook and cert manager deployment all taken care of. So let's click next, because the segue that I wanted to go into is Rancher is a Helm chart, essentially. Just like most applications for Kubernetes clusters, we deploy it as a Helm chart. So when we do Helm repo add, we're actually going to add the Helm repo that we have for Rancher. So if we click this here, we're now on the install Rancher step. We should be about like 25% of the way through the lab or the practice, whatever you want to call this. And then we clicked on Helm repo add, and it should say Rancher-latest has been added to your repositories. And then from there, we're going to go ahead and install Rancher. What this installation does is to have it have a host name, we're actually going to use slip.io to have it like a DNS that we can reference. And then From here, we're going to set it to a version 2.73, and we're going to create a namespace like we did with Cert Manager. So if we click on that, this will take a second, and it's going to say happy containering right there. So we're going to go, everyone should have ran that helm install rancher command, and we're just going to go next.
And one thing I forgot to mention, or did you mention, about the importance of DNS?
No.
Kubernetes loves DNS. Why? Because there are so many IP addresses. Every one of us has an IP address. You know, there's just, and guess, we're using that 10 dotted number. So we're using an IP number scheme that can go up into the bazillions. So how do we manage things? We cannot manage them by IP. We got to know names. So DNS is important. One of the resources you'll see is a core DNS pod will be deployed into your Kubernetes cluster to help manage all of the DNS names that will be created for every one of the resources that shows up in this Kubernetes cluster. Hobby Farm can get very overloaded with because it's up in AWS, so it's with everybody doing something.
Is someone having an issue with their Hobby Farm instance?
Is it slow or is it just working?
Within the terminal or like the actual? Huh. Give it are you on Windows? What's like the cache, like recache the website, refresh for Windows? Like if you're on Mac, it's Command-Shift-R, huh? Can't remember. It's been so long since I've used Windows. Control-Shift-R? Okay, yeah, that would make sense. Command-Shift-R is for Mac, so. All right, so if you're on this page with me, verify rancher is ready to access. We ran a while true command, and it's going to be basically checking whether or not this HTTPS, the website is actually available. It did that for a brief amount of time and then said it wasn't ready, but now it says rancher is ready. So I will go on to this next page. Again, raise your hand if you're having some, need to get caught up, and Brian can come over to you and kind of assist. So now we're in the page where it says accessing rancher. So to note, what we're going to start doing some manual command pasting to get some a bootstrapped password. So first thing that we're going to do is go to this page here. If you just click on it, it should automatically open. The connection is not private. We're just using self-signed certs. So what you're going to have to do is go to advanced and click on proceed to rancher, your guys' IP address, .slip.io. And if you do that, you should be good. You can also, if you don't have the proceed to rancher button, this is unsafe. If you just type that into the web page, you can actually get past this connection is not private.
I had a question back here, Austin. The SSL IPIO, that is only what we're doing in Hobby Farm. You will not see this in your own labs. You'll never use this for yourself. This is just for us to provide DNS inside of Hobby Farm. So it's just a thing there. Don't remember SSL IPIO. Don't remember that. Doesn't matter. Yep. It's just in this lab.
Yep.
But you need to see this. This should work.
Yes. So now this is where you need to actually get that bootstrapped password. So as you can see here, it says for a Helm installation, you need to run kubectl get secret, and it's just going to decode the bootstrap password because it's just base 64 encoded. And you're going to copy this. So if you click on that, kubectl secret command, and then you actually come back into your terminal, you paste it, and then run it. It'll actually spit out your guys' bootstrap password. So then you copy that, and again, this is in the Rancher 01. I want to make sure that everyone's got the Rancher 01 tab selected as of right now. And then you take that bootstrap password, we can verify some things here, BVG, BVG, and then CWV at the end for me. I guess you guys don't need to hear me saying that. And you log in with local user.
There is a way before you install Rancher that you can specify your own bootstrap password. We didn't, so it generated its own. But we talked about how things are declarative. One of the things we can do when we install Rancher is we can use a declarative file to tell it, here's what I want your bootstrap password to be. Here are some other values that I want you to know about. Go. and then it will use your own password versus something like that.
Cool. And so here I'm just making my own password real quick, where the server URL should automatically populate for you guys using that slip.io. Make sure you check this. By checking this box, you accept the end user license agreements, the T's and C's, and click continue. So we're logging in as the admin here, and then we're going to end up on the Rancher landing page. Yes, it is admin. So if you for whatever reason needed to close down the browser and bring it back up and go to your slip.io for Rancher URL, you would log in with admin. And you can actually see that up here in the top right. There's going to be a little, creature and admin. So, sorry. We've got Rancher deployed. So just to reference this page is the dashboard. I'm going to try and command that. Perfect. This is the local cluster. So like I said, Rancher is deployed into a Kubernetes cluster, and then it is going to manage other clusters from that said cluster. I have seen this with a few customer calls. The local cluster is not for workloads. You'll mess up a whole bunch of stuff. So this is just for Rancher. We obviously have some tools that you can deploy in there, like Prometheus and Grafana, to have observability of your local cluster, as well as a backup tool, so you can back up your actual Rancher deployment. But this is not where you put workloads. But it is good to note, because then you can see things like, how many pods are deployed. You can see how much CPU and memory that this node has. You can see the version here, and so forth. So everyone should see this. Everyone should have it up and running. I'm going to, Yes, the local cluster, yeah, perfect. Great. Thank you. Yeah. So the local cluster is the Kubernetes cluster where Rancher lives.
So it says 29 out of 110. Does that mean that it's trying to scale up to 110?
So 110 is essentially the base limit that we put for pods to be in a singular node. You can change that and adjust that, but that's saying that there's just 28 of 110 pods deployed. So do you remember when we did kubectl get pods? If we did that again over here, it would have a larger list. So I can go off script here real quick. If you guys want to either go up on the arrow keys and do kubectl get pods. I should have just typed it out. But kubectl get pods all namespaces. You can still do things within this Kubernetes cluster from this terminal, and you'll see kube system. But now you'll see things like cattle system namespace, which has our Rancher webhook. You can see the cert manager that we deployed, etc. And I can actually show you what that looks like further. So what we'll do is go to this next. We're in Hobby Farm right now, and we are going to go to the step that says creating a Kubernetes lab cluster within Rancher. So I'll show you how you can actually run the terminal within Rancher for your Kubernetes cluster and other places within Kubernetes, within Rancher, and therefore your Kubernetes clusters. So let's go ahead, and what we'll do is navigate back to your web browser that you have Rancher's web page, and we're gonna go to click on this create button. If you're not on this page, just go to the hamburger menu, click on home, and come and click on this create. So this is saying we're gonna create a downstream cluster. And what we're going to do is we're going to create another RKE2 cluster that we can actually put workloads on. And for this example, this demo, it's going to be a WordPress deployment. So just to show you guys to walk through this, if you deployed this cluster in the same manner at home, and you guys have access to Azure, AWS, or GCP, you can actually use your guys' secrets and access keys to essentially deploy more clusters downstream, but they'll live in those clouds. Yeah, if you go, there'd be some networking hurdles, but yeah, exactly. And so then if you wanted this, you'd be able to deploy. Sorry, this first page, or this top section, is actually going to be deploying different genres of Kubernetes distributions. So AKS, EKS. This section right here actually deploys our version of Kubernetes, so our distribution. See here we have it toggled as RKE2 or K3S. We also have a version called RKE1. It's got a Docker shim as the runtime, so we really just recommend stay up to date, because the RKE1, we still from a support standpoint, yeah, people are using it to this day, but we prefer people to use RKE2 because it kind of fits more of that Kubernetes standard. But anyway, you would deploy EC2 instances, or you could use Linode, VMware, DigitalOcean. There's actually even other drivers that you could come here and look at. So there's cluster drivers. These are not necessarily out of the box ready to go. There could be some configuration, but these are some other Kubernetes distributions, so cluster drivers. And then there's also different node drivers where it would deploy with RKE2. And so you can actually look at all these. So you've got Nutanix in there, OpenStack, et cetera. But let's get back to, I'm going to have to go back to the home page and click on that create button again. So where we're deploying is we're going to scroll down to the bottom, make sure that, oh, why is this not scrolling? There it is. Make sure that the RKE2 is toggled, and then we're going to click on custom. So this is going to say we're essentially going to deploy onto a bare metal node. In this instance, it's a virtual machine, but yeah. So we're going to click create, and we're going to change some things. Let's make sure that we're following along with the steps. So we went to the Rancher homepage, we clicked create, then we scrolled down to the custom cluster on existing nodes. In this section, we're going to have some things that we need to reference. We need to give it a cluster name, and then we're also, for later purposes, we're going to give it an older versioning. So let's go back to our Rancher deployment. Let's take this and give it a name. Let's see, Arcade, so Rodeo, let's do SCaLE. You can name it whatever you want. Do use lowercase, please. Otherwise, you will have an error. And then come into this drop-down menu, and you can actually select the 1.23 version of RKE2. And then we're going to leave everything else as default. So just like with the RKE2 cluster that we ran that curl command, and we did kubectl get pods, we noticed that the services, core DNS, Nginx, metric server, those were all deployed with the curl command. But here we can actually start doing things like adding member roles. So if we wanted to do some role-based access controlling here, we could add a member to this cluster and give them read-only access. So the end user is somebody that doesn't get to actually deploy anything, but they have access to some internal documentation or something like that, and so forth. But I'm going to go back to this basic cluster configuration portion right here, scroll down to the bottom as long as we have the name and the Kubernetes version as 1.23, and we click create. And when we click create, we now have a registration command, and then we have some other steps. So if we go to the hobby farm, we've accomplished steps up to 7, and now we're on step 8 and 9 and etc. So what we need to do is look at that registration command. We're going to check out what roles we're defining for this downstream cluster, and then we're going to click on Show Advanced. So we're going to look at the roles. We have etcd selected, control plane, worker, and then we also have the command itself. First and foremost, we're going to click on Show Advanced, and we're going to come over here, and we're going to copy and paste from our Hobby Farm tab our private and public IP addresses. So this is where we got to do some, make sure that we're using the right tabs and et cetera. So to be clear, make sure that you have this Rancher tab selected. Make sure that you go to the private IP right here, do a little copying, come back to Rancher, go to the private, 1.7, yep, there it is. And then if you come to the public IP, copy that. Boom. And we now have Host name, you can just leave that blank and it will just automatically name it. You could just give it something if you wanted for your own case, but I just leave it blank and it'll automatically assign a name to it. Okay, the cluster's IP, rancher's IP. So so again, because all this is done through HTTPS, we're actually referencing that is actually the rancher's DNS, right? So that's that slip.io. So in this registration command, it's talking up to our rancher deployment in order to have the downstream cluster basically get observed. And yeah, does that make sense? Because it's not just the IP address that's being referenced in the command. It is it should have your, oh, you know what? I am super silly. Holy cow, thank you. Thank you. I messed up. See, this is what I'm talking about. I need to talk this through better. Holy cow. We're not referencing Rancher. Please do not paste anything yet. So come back to this cluster 01. What's your name in the red? You deserve something. Max? Thank you, Max. So actually come to this public IP of cluster 01, and we're going to replace those things that we just previously did. So we're going to change those to the cluster 01 private and public IP addresses. They shouldn't be. So in the node public, use the node private for, yes, you could just use the instructions. So this is the cluster 01's public IP address, and this is cluster 01's private. If you notice here, I have this tab selected, and I had previously selected Rancher 01 on accident and started copying. Big mistakes, but if you actually followed the instructions, you would have been able to just copy these into those fields. See how it says very important? Thank you so much, Max. That was so great. So then we need to come back here, make sure that we've got the right IP. Just for sanity check, you can look and make sure that this node public IP is not the same as your Rancher deployment's IP. And then if we scroll to the bottom, we actually need to skip the TLS verification because we just have self-signed. So make sure you have this highlighted. Now we have a registration command with the appropriate IP addresses. Whew. Cool. So let's just not paste yet, and we're going to go to the next step. So let's just briefly look at this and say, start the Rancher Kubernetes cluster bootstrapping process. So we need to make sure we have selected 01 in Hobby Farm, cluster 01, and then we will run the command that we got from our Rancher deployment. So come here, click that, it says copied, you should be good to go. Then we run this command. I've pasted it in there, just click enter, double checked and made sure that I had cluster 01. And then if we want to just get some provisioning steps, you can actually navigate to this, to the Rancher page, and you see here you got some bootstrapping information, and you can actually click on the provisioning logs. This will be saying updating. You can actually look at the machine pools. So it automatically gave a node name as you know, because we didn't name it ourselves. So it's got custom. It has the OS as Linux right here. It has all the roles because we defined it as all the roles in the registration command. You can look at the conditions. You can see that there is no cluster agent deployed. So that cluster agent is what's talking up to Rancher. So that is a distinction I like to make because it allows for us to operate in an air-gapped environment. The Rancher cluster is actually not going around and digging up. The downstream clusters are sending information up to the Rancher cluster. So that's something to note for air-gapped environments. Let's go back to the provisioning logs and just wait this out. It should take about like 5 minutes and we should have another cluster up and running. Again, this is the downstream cluster. So this one, yeah, so for the downstream cluster, you know, yeah, it's just a singular node. like test environment. But if you wanted like highly available, the minimum's, 3. Yeah, so. Question in the back? You can deploy it, best practices would be to deploy it into a Kubernetes cluster. You could use Docker instead of the way that we did, but that's like a deprecated method. But those are really the 2 deployment methods, yeah. Yes, you would use the Rancher management cluster first before making any downstream clusters. But to note, that's a great question because I can actually show you some information here. I'm going to let this just run. But if I come to cluster management, I can actually import existing clusters. And you could do, again, clusters if you already have them in your cloud providers. You would just go there, enter in the, you'd basically make your, here. So your project ID, the cloud credentials, and then it would have a list. Or you could, let's go back. Or you could do, so for instance, if you made a vanilla cluster with kubeadm, you could just type this out, kubeadm. You would click create, and it will give you a command to import existing Kubernetes clusters for Rancher to then manage. So you could do that, but if you wanted, like, I think the one thing about imported clusters is they don't do certificate rotation automatically. So you'd have to do that yourself. But if you provision it through Rancher, whether it's in the cloud, or if you wanted to do it via like the bare metals, the cert rotation is a lot more accessible. So I'm going to go back here and go to cluster management. I'm going to go into the SCaLE. I named it SCaLE Rodeo, and I'm going to check on those provisioning logs. Should just take a little bit. Is anyone having any issues? Is everyone pretty much waiting for this to update? Yours is done? Yours was quicker than mine? Yep, when it's in machines, yep, mine just finished as well as I was saying that. So it took, as we could see, we now have 2 clusters running. It took about, 8 minutes to get the second one going just from like sending the command down. And you can look at things like the machines. You can see what IP address, both external and internal, those are the ones we provided. You can go through the conditions and make sure everything's up. So it looks like the cluster agent, yep, that is no longer there, obviously. It deployed 1 minute ago. And yeah, there's just some more information here, related resources, and so forth. So if we go back to Hobby Farm. Great question. So the question is, would we use the same command for every node? That depends on how you want to set it up. So if you wanted one with all roles, then yes, but that's usually not the case, right? Like, so you would end up selecting, deselecting, depending on what your needs are. So, for instance, if somebody has, their workloads take a lot more CPU, they need more worker nodes. So they would then add worker nodes via this command, and then you'll see in here there is tac worker, and if we were to remove that, control plane, etcd, etc. So, I mean, the big thing is that it's resource constraints, right? Well, yeah, because it's going to deploy essentially those same like cube system pods into those nodes as well. So yeah, and especially like once you start doing things with like edge deployments, that's where that can become quite important, right? So like if you have a worker node that you want to manage, but you don't want it to have the data stored, and you don't want it to have all of the control plane tools in it, you just want it to be a worker node on like a Pi, then yeah. So
What this did is since we did a custom deployment, created a virtual machine, which is the node that we install stuff.
It didn't, so because it's a custom deployment, it didn't create a virtual machine. It was a virtual machine that we had already set up. That's why in Hobby Farm, if you go here, there's 2 tabs. So it was as if we had like think of like a bare metal. So if you had like a Raspberry Pi at home or a Nook or something like that already set up with an OS ready to go. That's what happened. If
How do I register those? Let's say I've got 5 Pis
uh-huh.
and I want them all to be used as nodes.
Uh-huh.
How do I?
Well then in that case, you would just run this curl command on each of those Pis.
And then that would have the individual Pis register with.
Yep, and it would become one cohesive cluster. Yep, exactly. Perfect, great questions, guys. So, oh yeah, and if you wanted to use a Windows machine, you could, but you know. Anyway, so as you can see here, we went through the machine pools, we went through the conditions, we made sure that everything changed to active. So just for some clarity real quick, I'm gonna go to the machines. We've got it running, we have it active. Everyone else should be in that state as well. So I'm gonna click on next. And yeah, so we can actually start interacting with our Kubernetes cluster, the downstream cluster. We've already been interacting with the local cluster, which is obviously the Kubernetes cluster. So if you come into cluster management and you want to look at the things that are deployed on your Kubernetes cluster, you can go to Explore, and this will give us some cool information immediately. So this is the cluster dashboard. Yeah, absolutely. You can. There's a few ways to do this. If you go to the hamburger menu, there's going to be, these are the global, like global apps, but also, and under those global apps, there's cluster management, or they have the Explore cluster tools built in. If you click on your cluster that's not the local one, just click it right there, or go to cluster management, and then go to Explore, and we should be on the cluster dashboard. The downstream one, so not the local cluster, whatever you named, yep, the custom cluster, correct. Yes, yes. And so, you know, we're gonna leave that cluster alone. We're not gonna deploy anything else on the Rancher cluster. We're gonna be pretty much operating solely now in this, what we would call downstream cluster that is a custom cluster. So, I'd like to show you some things right off the bat. You can see the provider that we use, so RKA2. If it was like a K3S, it would say K3S right there. It gives you the total amount of nodes. We have 1 node, we have 10 deployments, 410 resources. It gives you some information about CPU, the memory, and then the total amount of pods. But the cool thing that I like on this page is you can actually go into the kubectl shell if you click this. And depending on who you're signed in as, you can actually start running commands. So if you tap on that real quick, you'll see that we have, in the top right, you basically have a profile photo. This is the default admin. And so if I am signed in as an admin and I click on this kubectl shell, it's just a greater than sign, you know, yeah, anyway. It will bring up a shell, and you can start running commands as the admin of the cluster. So kubectl get all, or get pods dash capital A, and you can come in here and you have another way to interact with the cluster. So previously we did that on the terminals and we were able to see all of our pods, but we can see now what we've deployed with RKE2. So we can see that in the kube system, we have those same things that we've already seen before. We have the Helm operator, or we have in the cattle system, we have our Helm operator, our fleet agent, etc. And so that's where the Rancher webhook exists to speak to the upstream, or the local cluster right there. So yeah, pretty cool. You can also download that kube config, and if you have kubectl installed on your own terminal, you can actually take that config, make it into a file on your local terminal, export it, and then you can just start running commands and easily switch between like different clusters from your own terminal, as long as you download the kube config for each of those. So pretty cool. You can also just copy it if you wanted. So yeah, that's just some quick ways to interact with your cluster. And so we did the kubectl commands. I showed you all the kube config file. And now we're going to start deploying applications. The first thing we're going to do is we're going to actually enable monitoring with Prometheus and Grafana. So if you come into your Rancher deployment, you will have this hamburger menu. Make sure that you've selected your downstream cluster. And if you have, you then should see cluster, you should see workloads, and you should see apps, and then some stuff below it. If we select apps, we're actually going to go into the charts page. So we're selecting charts, and the really cool thing, we had a slide that represented all of this. The things that come built in with Rancher, the things that we manage ourselves over at SUSE, we've got the CIS benchmarks, we have Istio, Longhorn, we have NewVector, which is a really cool container runtime tool that is basically principled behind some zero trust principles. So it's like, if it doesn't recognize the programs being ran in your containers, it just doesn't let them run processes. So pretty cool. But as you can see here, these are the applications that come with Rancher, all in blue. If we go lower, these are our partner charts, and these contain Helm charts. Just like we previously deployed Helm charts with the command line, we can now do that within the app's catalog. So we're going to click on monitoring, like this says here. So enable Rancher monitoring. To deploy Rancher monitoring, go to apps. We're there under charts, locate monitoring. We did that. And then we should be on the install button, or we should select the install button. So this gives you some information, gives you some versioning, and so forth. So you've got a nice little README here. You can click install now, and it enters an install wizard. And then you can select like what project to install into, and I'll explain what that is later. But we're just going to leave this as the default options, because we're actually going to then change some information on once we click the next. So if you see up here, we have metadata and then values as the last step. If we select values by going next, we should now have some option pages. It automatically detects the cluster type. We're going to leave all of these things as default. We're going to look at these options over here, and we're actually going to click on Prometheus. So if we go to the instructions, it says, in the values step, select Prometheus, and then we're going to change our resource limits. Because we're on a singular machine, the default CPU limits that monitoring uses is going to be this, but we don't have that many resources on these singular nodes. So we're going to change this from 750 lowercase m to 250 lowercase m, and then the requested memory we're also going to change from 750 to 250. Make sure that that's what it says in the Hobby Farm steps. Yep, so for CPU and for memory, and then we're going to click on install. And like I said, pretty much Helm is like the standard that we use and many other people use for their package managing. And now you have an application deploying. It's essentially a Helm command because it is a Helm chart. Yep, Helm upgrade, but it's actually saying install equal true. We create this namespace. We've defined some versions like we did previously with Rancher and with Cert Manager, and then we've noticed success. So if we come back over into Hobby Farm, we should be good to go. It says installed apps, and now we should be on the step that says working with Rancher monitoring. So in the left menu of the Cluster Explorer, we're going to select monitoring. So from here, we previously have this. We might need to refresh the page. So I'm going to minimize this. So we'll have cluster workloads, apps, service discovery, etc. But if we maybe refresh the page here, monitoring should have successfully deployed, and now we have a monitoring option. So if you select that, you now have a dashboard for monitoring. And if you click on the actual metrics dashboard for Grafana, it looks like it just needs to come up briefly. So it's still deploying that. Let's check on the workloads. So if you wanted to check in on your monitoring deployment, you can come up into this all namespaces section, scroll all the way to the bottom where it says not in a project, and select cattle monitoring. We do note that you're doing this because we're going to want to change that after. And if you look at this here on the left, we'll have some information. So this is saying it's constantly looking at the cattle monitoring namespace, cattle monitoring system namespace, and we actually have 15 pods. We have 2 stateful sets, 8 deployments, and 5 daemon sets. So we're going to see if all of these are up and running. And as you can tell, there's all these should be active. Yeah, it looks like they just barely became active like a minute and a half ago. So that's probably why when we selected the monitoring page, it sent us that error. So we've got a lot of information immediately. Let's go ahead and go into the monitoring page down here. If you're following along, you'll be on the monitoring dashboard. Let's make sure that we deselect this cattle monitoring filter. So this is a namespace filter / project filter. Let's just do only user namespaces up there and make sure that that's what's selected. So click on Grafana, and this is the application we just deployed. You can federate your other clusters and have it all reference the same Grafana. You can obviously go in here, follow their documentation, and you'd be able to change what's being represented here. But you got memory utilization, CPU utilization, disk utilization. Immediately have visibility into your cluster. And in fact, if you are in Rancher again, I'm just going to close this Grafana web page. If you're in Rancher and you select cluster, end up going to cluster dashboard, we'll immediately start having some metrics showing up. So this is Grafana. It's embedded into that cluster dashboard, and you can see those metrics. It's quite cool. So yeah, if we go back to Hobby Farm, it looks like we're good to go to next. We've covered everything in the working with Rancher monitoring step, and now we're going to go into the create a deployment and service step. So if you remember, we talked about pods and deployments. We're now actually going to create a deployment which is made up of pods. So if you go to Rancher and you go down to workloads, you can either select workloads and click create, and you can have a list of things that you can create. And what it does is, references cron jobs, daemon sets. So daemon sets essentially say, I want this to run on every single node or host within the Kubernetes cluster. Stateful sets, these are for like stateful applications that need to basically be persistent. So these are not ephemeral. They're going to have like some persistent storage attached to them. But for this demo, let's click on deployment. And now we've got some fields to fill out. So if we go back to if we go back to Rancher's Hobby Farm, and the first thing we're going to do is grab this container image. So it's going to be Rancher / hello world latest, right? And then we are going to go down to this first step and start listing off some more things that we're going to add. So if we go into Rancher, the first thing we're going to do is give this deployment a name, hello world. We're going to go down to the container image, and the container image is going to have that Rancher hello world -latest. So I'm going to paste that right here. And then in this section right here, we're going to actually pump this up to 2 or 3, or however many you want. And then from here, we're going to go down to a port, and we're going to add a node port, which, if you remember correctly, node ports expose an application to the outside of the cluster. So it's like essentially you have an application that opens up a port for outside use. So if we do that, we're going to scroll down. Did I see a hand, by the way? Was there any? Oh, okay. So we're going to click on add port. If you saw that, add port or service. So this is what it looks like, add port. The service type, we're going to select node port. I'm going to just say hello world -np, and then it's going to have some instructions. We're going to do serve it on the private container port on 80, and I believe that's all that we need to do. So there's obviously some other options, like the high port will automatically be created for us, but let's see, I'm pretty sure, yeah. So now we can go scroll down to create, and now we have a deployment. So this immediately says like, hey, this is how old this is. We have 0 of 3 in the ready state, and now we have 3 and 3 in the ready state. Took 2 seconds, and we have a whole this allows workloads to be deployed or not. So that goes at like the node level. So for instance, when you have a downstream cluster with the control plane installed on it, and just the control plane, it will actually implement some of those taints, right? Yeah.
Mm-hmm.
It will say nothing else is schedulable except those control plane pieces. So you automatically don't have, all these workloads deploying onto your control plane. So you never clog up like the Cube API server.
You would just use the CLI to do that.
You can do that, or you could do it within Rancher.
And you used the word cordon, which was an interesting word to use, because there is a word called cordon, which I can run on a node and tell it, you are taken out of the cluster. You do not play a role anymore. Whatever you were doing, I'm taking, because maybe I'm going to do upgrade of you. I'm going to upgrade the RAM in your box. I'm going to shut you down and upgrade the RAM and bring you back up or do something like that. Then you would cordon the node off so that the scheduler doesn't try to continue to repurpose things to it.
So that's like maintenance mode.
It's like a maintenance mode. Or you're doing forensics, or you're doing all kinds of things, but you're basically taking it out of commission for a little while. And it's called cordon the node. And then when you're done, uncordon, uncordon, cordon nodes 1, 2, 3, and it does all 3 of them. Uncordon nodes 1, 2, 3.
So what does drain do? Does that just say move all the pods off of
And some people will do a drain first, and then because I can cord the node, take you out, but not have drain first. Actually, I think cordon may actually drain you drain the pods and take you out of commission. But it has to be both? So the drain is kind of cool so that you can get the pods off of it.
So for that it would actually terminate those pods, but bring it up on another. Based on what your deployment said, do you have something that said that this has to be alive and running? Because this thing here, if you killed this, if you drain that, it's not coming back. Well, that's actually deployment because you said you wanted to have 3 running. But if you just said kubectl run nginx and I spawned off an instance, and I didn't tell it that I wanted to have a replica set that says I want to always make sure that something's running, if I were to drain it, it wouldn't go anywhere else because the scheduler was never told to be able to monitor that.
Yeah, if you can actually, and if you do it through Rancher, it actually does like a rolling update. So it would automatically do that for you, and then just if you have an actual, production-ready cluster, it'll just individually take one node offline, drain it, upgrade it, bring it back up, and then put those.
And then uncoordinate.
Yes.
And in fact, inside your deployment manifest, you tell the system, hey, I always want to make sure that when I do a rollout, when I want to do this kind of thing, when I want to upgrade things like this, here's my percentage of nodes that must always be available. So it already knows if I've got 7 nodes in my cluster that I can take down 2 at a time because I've told it that I want to make sure that I've always got 33% of my resources always available, my nodes always available. I think it asked for a percentage. I don't remember exactly. Well, what's your question again?
Because you said that you do a rolling upgrade, but that's on the application level. What if you're trying to do a patch on the server?
Which is the same, apply to patch.
So it will do the server and the application? Is that what you're saying?
So in this instance, we're referencing like upgrading the Kubernetes cluster version.
Right. But not the OS,
Not the operating system for the underlying host event.
But if you had to upgrade the operating system, you got to do the same thing. Particularly if you've got to take it down and do a reboot, then you'd want to drain it, coordinate, apply your updates to the operating system, patch it, do your kernel updates, reboot. When it comes back online, it would then be added back to the cluster.
We actually have a tool called Elemental that allows you to build like basically a containerized OS, and you can manage the OS upgrades as well on your underlying nodes, all through Elemental. So
All through Kubernetes. Use a Kubernetes to do it. Yeah. Yeah. Yeah.
what were we even doing? Okay, yes. Now we have, I showed you guys these nodes here, but we're going to go back into deployments. So if you click on this workloads and you have only user namespaces filtered up, you should have this hello world, and you can actually see that the endpoint is being served. Oh, make sure that well, I guess we're not serving that workload.
Look at your service. Is your service up and running? Hello world, there's 80.
Yours is working, then apparently mine. There's this one, right? Okay, that makes sense. So this is actually referencing the cluster. It's going to the KX clusters, and it's serving this. That's our workload being exposed on that node port. So this is saying the node port is actually 80.
80 and not HTTPS. You clicked on the 443 one.
Yeah. And then we have the actual Kubernetes like cluster IP right there. So we continue, or pods IP right there. So now that we've got that deployed, we're actually going to deploy another tool here. So we're going to create an ingress. That makes sense. This next step here is we're going to go down to service discovery. We're going to expose traffic via an ingress to those pods. So first thing that we do is we end up back in Rancher. I'm going to close a plethora of tabs that I've opened. We're going to go down to service discovery and ingress, and we're going to click create. So from here, we're going to enter in hello world. Oops, that's the request host. The name of it is hello world. And then if we copy this request host, we're going to put that into this, and then we're going to define a path. Just backslash is fine. And then I believe that's all that we need. Oh, port 80. So we need to select the port that is currently being used. Since we defined hello world node port, and then we're going to do 8. And so that is from when we created the hello world. We also created a service, and that service is the node port, and we exposed it on port 80. If it was something else, it wouldn't say like 8080 here instead of 80. And then, as you can see, it says click create. And it is now active. So essentially, if we complete that, means now we should be able to go into deployment. Click on hello world. It should. Oh wait, sorry. Go to services. Go to ingresses, and if we do hello world slip.io, that's where I want to go. We'll actually have that ingress hello world serving on our host, which is the public IP of the host node that Rancher's, or the downstream cluster is installed on, and then we have it exposed in. Perfect.
Go back to Ranger.
Yeah.
How you guys are.
Absolutely. So in service discovery, we have gone down, clicked create on ingresses, and then if you just click on the target, HTTP hello world, it should take you there. Yeah, you're welcome. Okay.
And the beauty about that ingress, by the way, is we chose port 80 because it's an easy one, but you could have chosen 32767. You could have created a whole bunch of things, but you would never want to tell somebody about a port number to get to your website. It would never be a good idea. But the ingress, as you saw in that definition, told me which port to use and gave me the name that I was going to pick, and so therefore it matched the two, and I said a path was slash, so I just gave the URL with the slash. It did all the translation behind the scenes and took me to that location so that I don't have to tell people about port addresses.
And that kind of comes back to that slide where we had like a user requesting or sending traffic to a specific portion of the website, and then the ingress directs it to a service type. This service type is a node port. It could also be a load balancer. It's just again that abstraction of different nodes or different services. Yeah. So because because the service we use is a node port, then yes, it could be different nodes, or you can just do like a different service within the same node. Does that make sense?
So what happens if, say, I'm running like a web server and I've got routing for, different pages depending on, I'm sorry, I'm drawing a blank. The thing that comes after the slash and the URL.
Mm-hmm.
Like, how does that work if it conflicts with what I've specified in Rancher?
If it conflicts,
Well, we're doing the routing for you there, so you don't need to do any other routing. We're specified it all right there.
It's the same service, right? Does that make sense?
No, it doesn't make sense. What's the question about the service?
So you know how you can specify a service, the path, right? So if I've got max.com/blog, right? And that's like a one page on my website, max.com.
Okay? So you specified blog right there.
Yeah, right. And let's say blog goes to some website that I'm hosting, like it's a
Yeah.
web server running.
That's the web server right there.
So what if I've got a different page on my website that's /blah/blah?
Okay? You would create another rule and you would point it to the new location.
Otherwise, it would be like not found. Does that make sense? Wouldn't it be the same? Like, what if the blog is the same service? So right, it's just a different path, and then let's say I've got like a Next.js server or something that's handling that.
Oh, like a different path on a web server. You're just trying to specify on the same. Well, I guess the question then is, it wouldn't matter to us as long as your web server, whatever this is pointing to from the original one, as long as it knows how to handle the address, we're going to send it to it. We could point it to the same one. You could point them all to the same URL.
What happens if it conflicts? What if, I've got /blah/blog handled by my web server, but I've also got some other target service specified here at the same path?
Well, that would be a problem. There would be a.
Handled here first.
Well, I guess it depends on where does that packet go? Does it come to here first, or does it go somewhere else first? If it comes here first, then we're going to follow the path here that's been defined. So the real question will be, where are you defining all these other paths?
Okay, yeah, which would be in the service. So it would come here first.
Yeah, it would come here first. You were going to.
He's talking about web addresses which have a path after them.
Mm-hmm.
So in your target service, can you have a path chart?
Well, and that's what we're doing here, is we're specifying the path here that doesn't, this path that we're specifying here, blah, isn't defined on your web server. It's just something that we are creating that when you type in the path and you specify something that matches here, we do an automatic redirection.
What do you redirect it to?
Whatever you select in this drop-down service, the target service.
So that target service, can you have URL section into the website?
Sure, I guess so. I haven't. Yeah, and that's what I was saying to him. It all depends on what his web server's been told.
But using the example with the 480 doesn't, without a path on the target service, that doesn't get the point. That's as if you're rooted.
Correct. And the reason we're doing this at all is because your choices are if I have 27 web servers that I want to provide access to, do I have 27 IP addresses that are unique to the world that they can all point to? Or do I want to have 27 slashes? Here's one URL with 27 different slashes pointing to each of the different ones? Or do I want to have a load balancer that knows about 27 different public IP addresses that I'm going to point to? So you got to pick, how am I going to route between them? This one requires only one IP address, where a load balancer says I've got to have an address for every single exposed service that is unique. Question back there? So one of the things he was talking about is how we rewrite that URI that comes in. If we go back to that CNCF chart of like 200 people, guess how many ingress controllers there might be? Way more than one. And so the capabilities that you're going to have will be different based on which ingress controller. Here we're using Nginx, but you could use a whole host of others, and they would have different capabilities.
Cool. So let's get to a point where we can actually start deploying another application. So if you go back to the Hog Farm, I'm on the page that says create project in your Kubernetes cluster. That should say 69%. So got some information here. So we have the project, and then the project default, and then we have the project system down here. So projects are an abstraction on top of namespaces. Rancher actually did this back in the day. Upstream Kubernetes was like, hey, that's a good idea, and they have actually made it their own, but they call it hierarchical namespaces. So there's like a hierarchical namespace on top of a namespace. Same thing with the projects. So what we'll do is we'll click project, and we'll actually name this stateless-WordPress. So as you can see here, we went from cluster to then projects and namespaces, and then we clicked on create project, and we named it stateless WordPress. And if we click create, there's also really cool benefits to this. You can actually assign users to projects as well. So for instance, if you've got like a project for at A, you can give users access to just that project inside of that cluster. So it allows for a whole lot of other RBAC use cases, so role-based access control. So if we click create, we will now have a project listed, project, stateless WordPress. If you click create namespace, we're also going to create a stateless WordPress namespace. You can do some things like container resource limits. You can actually limit namespaces to a certain amount of resources, but we're just going to leave everything as default and click create. So where we should be is in the projects and namespaces of your downstream cluster, your custom cluster, and you should have a project, and it should say stateless WordPress, and within there you should have a namespace called stateless WordPress.
This is specific to Rancher. This is not part of Kubernetes. This is kind of what you're adding.
Yeah, that's a tool that we added, but Kubernetes, upstream Kubernetes, like if you were to spin up a vanilla Kubernetes cluster with Kube ADM, they have that hierarchical namespaces now. But yeah, this portion is specific to Rancher, because they adopted our use case essentially. They took that and made it their own as well. So we're now going to add a repository. So in that apps catalog, there's a whole bunch of applications that were listed. So if we come into Rancher, the first thing we'll do is go into that left menu, and we'll click on apps again. So apps, and then repositories. So with RKE2, when you create a downstream cluster, these are the repositories that automatically get pulled in. You have the Rancher charts, and then the partner charts for apps. And if you click create, we're going to name this Rodeo, and then we're going to come back to Hobby Farm and copy some stuff. So we have this index URL. We're going to select that. Come back to Rancher. Paste it into the index URL. Make sure that we have the HTTPS URL index generated by Helm all right there. And I believe that is all that we need to do. Just double check. Yep. And then step 4, we click create. So now we have another repository in there. And what we should be able to do is, let's make sure that this is the steps that we want to go to. We should be able to go to apps in Rancher, then charts, and we should actually get some more options. So this is where I like to specify. Come into this filter, and you will see the all selection. Deselect that, and then go down to if you named that repo that we just added to Rodeo, select that, and then we actually have a whole bunch of charts that are in that repository. So now if you have your own repository that has Helm charts in it, you can actually reference it and have them just easily deployable from here. So for instance, if you want, you could deploy Tetris. I've had people deploy Quake, Cube into their clusters while we've been doing these and they've been playing games. So yeah, these are all applications and they all have Helm charts related to them. So make sure that you have this Rodeo filter on if that's what you named the repo, because
we're going to be using this version of WordPress. So if we select that, we should see that like essentially the README page doesn't have any chart information because this is all managed through us. And so if we click on install, we have some information here. So step one, we installed, we went to charts, and then we select on the WordPress app, all underneath the Rodeo install wizard. So then we should be able to select the installation into the stateless WordPress namespace. So in step one, you can select what namespace to deploy this into. So there's a whole bunch of namespaces, but we have this stateless WordPress namespace which we created previously. If you click next, we're now on a form that's going to have some information that we need to set. Let's make sure that we set that. So in the WordPress settings, we're going to select, we're going to create a password, and then in the service and load balancing settings, we're going to set a host name.
So who generates this page? Like, is this something that's coming from WordPress, or?
This is coming from the Helm chart values, and this is the installation wizard is something that we maintain for the fields, like these fields.
Okay.
Otherwise, if it's just from another repository, it would just look like this.
Okay.
It would look like.
Tell the maintainer there's a typo in WordPress username.
We will. So this is what it would look like otherwise, but yep. But because we have a field set up, WordPress password, WordPress, you never know when you need two N's. You need an extra one every now and then. That makes sense. So now we have WordPress settings selected. We've given it a password to this WordPress application, and then in services and load balancing, we're going to change this host name. So the host name is going to be WordPress. It's going to be WordPress, the public IP address of the node, and slip.io. And what this does is it creates that ingress with Nginx, and yeah. So we're exposing that FX7, and I think that's it. Cool. So if we click create, or click install.
What was the WordPress username, what was that?
That's in WordPress settings. Sorry, I will show you. It would just be user. The default one is just user, but if you come back into this page, it will show you kind of like an installation of what that looks like. We gotta wait for a second for this to deploy anyway.
Username.
Yep. So default is user. I gave it a WordPress password, and then I changed the host name to that WordPress and IP address and slip.io. So we can reference domain name with that ingress. Click cancel on this. So we have this shell popped up. We can actually even close that and come into apps, go to installed applications, and we can see that WordPress is currently being installed. You can see the values of the values YAML file, so you can see what everything is contained within all of that. So this is a URL of our Rancher server that is selected. It's in this cluster name. And then if we come back here, it should be up and running. So it's deployed. First thing to note is we can come over into workloads, and if we actually do project and filter it by stateless WordPress, we now have one deployment, we have one stateful set, and then we have two pods. So that is MariaDB, and then those are just some workloads, but then there's some ingresses that we actually created. So as you can see here in the instructions, it says go to services discovery and ingresses, then we click on the URL to access WordPress. So here's that target that we defined with that ingress. Out of the block. So
didn't attach this, I should say, to any kind of persistent storage. So if we were to redeploy the database that is referencing those posts, referencing all of the application, yep, it'd be donezo. So if we come into Rancher and we actually go into workloads, MariaDB, we redeploy this, and then we come back to this, and we thought we had this beautiful, wonderful blog post, and then once this comes back up, we would actually get a WordPress application with no information on it. You would have to start it from scratch. You would lose all of your settings, your user settings. It basically becomes a fresh installation of WordPress. So to avoid that, what we're going to do is now create a storage class that we can use to dynamically provision persistent storage. So we're going to use NFS, and we're going to do that by going into the application marketplace again. Also, does anyone have any questions? Do we need to take a break? We've been up here for a while, and I forgot to mention that we can definitely take like a 5-minute break if anyone needs to. Or I can keep chugging along. 5-minute break? Yeah, do you guys want like a 5-minute break? Yeah. Sick. I will do that. Cool. So 5 minutes, go get some water, come back. So now we can leave this all as default, and we click install. And so as you see here, it actually is setting the NFS provisioner as the default storage class. We previously did not have a storage class. So if you installed any other kind of container storage interface, you would also have options to create more storage classes. So like with Longhorn, with, you know, you could add things like, do we want these volumes to be encrypted? And so, yeah, you can select a whole bunch of different storage class options when doing that. But we should now have NFS provision. So that means we should be able to go look in storage and storage classes. So storage classes, and we have NFS. So
Check, check.
thank you. All right, that's much better. Okay, cool. So, as we wait for that to install, let's go look also in the service discovery and ingresses, and I'm going to close out of the shell because that's just giving us some information, and we have a stateful WordPress application. We've seen this before. We should all be familiar. It's just waiting to come up. I might have to just refresh the page, or let's go check in on those apps. So if you come into apps, installed apps, we're waiting for that WordPress application to be installed in the stateful WordPress namespace. Does anyone have any questions? Is everyone keeping up fairly well? Cool beans. Oh, one thing I would like to know, I forgot to mention because I think this is really cool. So if you were to go into like the pods section under workloads, you can actually you can also view the logs. I showed you that earlier, but you can make a shell to run commands like right into the pods container. So you're in the container actually running commands. So pretty cool, and another, just way to have access to all of your infrastructure. So just waiting, this is taking a second. Container's not ready. Oh, we should also note that there's going to be persistent volumes created within the persistent volume section of storage. So if we go to storage, persistent volume, we now have these PVC claims for WordPress. And it's using that NFS, and this was all created because we simply had a default storage class that this referenced upon creation. Yeah, exactly. We deployed the NFS server into Kubernetes. Obviously, that's not best practices. You'd want it not in the Kubernetes cluster. But yeah, you could reference it via settings and set it up so it's like external to the cluster, and so forth. Cool. So we've got the persistent volume that was spun up, and we've got claims that go with it. So let's go ahead and get going. So, let's log into the WordPress and create a new blog post. So we're going to select this stateful WordPress section, or the stateful WordPress .ip address IO. We're going to log in, user. Cool, and we're going to create a new post. Post. Stateful publish. So now, if we were to delete the Maria WordPress DB pod or click redeploy, we should see a different interaction. So we'll view this post here. So we have this up and running right there. I'm going to go now to the workloads. I'm going to go to pods. And if we're in stateful, we should see this pod here that is going to be referencing that database. So if we redeploy this, actually, let's do it this way. That is a stateful set, right? Yeah, it is. Sick. So what we'll do is we'll delete it. So that's going to go down, but because it's a stateful set, it always wants to be up. I just killed it. Somebody accidentally went in, they killed it, but the Kubernetes API, there's controllers that are monitoring that via that API and says this actually needs to exist. So it immediately spun it up again. So what we should see is this should go down briefly, but as we wait, it should come up with that reference to what this persistent storage in, let's see, persistent. I deleted not the volume, but I deleted the pod that is interacting with the volume. Does that make sense? So I didn't actually delete the persistent volume. I basically redeployed the portion of the WordPress app that takes care of that data storage. Well, then, yeah, then you'd lose your data. It's gone. Good question. So the question was, if you deleted the persistent volume, what would happen? Yeah, you'd lose the data. You'd have to have some sort of backup, and there's tools to do that. For instance, if you wanted to install Longhorn, it's another open source tool that we offer, and you can actually go through their backup volumes, and you would be able to back it up from like an off-site storage data store. So, you know, we try to offer pretty much all the tools, all the nuts and bolts for a Kubernetes cluster just within this page. So, yes. If we go back to this, it's saying database error, and it's back up. And we actually have that persistent storage. So, oh, question? Yeah, so that's the thing, is like you'd likely want it to be either in a different node, so you could do it through etcd, or you could have a server spun up outside of your cluster, and it could be referencing that, you know, like S3 buckets or anything along those lines. There's ways to set that up. But yeah, I mean, for like a highly available environment, if you had, you know, 3 nodes that were taking care of your storage, and you had all of those referenced there, that'd be, you know, highly available, because if one went down, it could just come back up, and you could either have replicas across those nodes of the persistent volumes, so it could reference those from any of those other nodes, not just the one. Does that make sense? Cool.
And all your major storage providers have drivers or plugins, CSIs, that plug into Kubernetes. So if you've got Pure Storage or something like that, some SAN somewhere, they have drivers that plug in that give you your persistent volume, so you can just make claims all you need, and it automatically selects and builds and creates and goes.
Yeah, so like for instance, the storage, yeah, so as you can see here, you would have like Rook, kubefs. These are all CSIs that are in the cloud native landscape. So, you know, name dropping, but Longhorn's right there.
A lot of people have something already built.
Yeah, pretty much these are just those data pieces. So for the cloud native storage, or there's networking, again, I'd reference Containerd. So as you can see, these are the big projects, the ones that are graduated. But cool.
I have one more question.
Yeah.
So right now you try to shut down or stop or force the pod. What would in that scenario, how would you actually stop it without having or without making it come back up? I know it's based on the replication.
So so if you wanted to kill the stateful set, there's that. I'm trying to think so when Rancher deploys something via Helm, it usually brings it back. Yeah, so that's how we just killed it. I was trying to think, there's some charts that get referenced in manifest files of the Kubernetes cluster that will just never be allowed to come down, like you're not allowed to delete them, because it would just break the cluster. But I'm just killing those stateful sets right now, and this should never come up again. So we would have to go re-provision the app, or redeploy the app, and yeah. But you could, in theory, redeploy the app and then reference that volume, just because that volume is still here yeah, it still exists, right? Okay. Yeah, I mean, best practices in regards to like deleting your application.
Well, you have to delete all of it. So if you have to delete the stateful sets or the replica sets or whatever your deployment created.
You could come in here and do like
if you deleted the deployment, if the deployment created it all, you go in and delete the deployment, it knows all of its resources to undelete. Or to delete, I should say, not undelete, but to get rid of. So get rid of your deployment.
To be honest with you, at that point, you probably want to be working with YAML files anyways.
Yeah.
To deploy and build the environment.
Cool. Yeah. But let's continue on. And so we've demonstrated that we can get that storage back up. And pretty much the last bit is we're going to upgrade the Kubernetes cluster. And so what that looks like is if you come into this hamburger menu, you click on cluster management, and then we go into this ellipses or kebab menu, and you click edit config. Just to reference this, you can do things like take snapshots of the cluster in its current state. You can restore from that a previous snapshot. You know, like I said, the rotation of certificates are right here. But what we're doing here for this is gonna upgrade, and we're gonna just edit the config. We're gonna change the Kubernetes version from 1.23 to 1.24 and click save. And so we should see this go previously, like current, it's not available right now, it's updating, but we will just wait for that to come up. And yeah, so I'm gonna click back into the cluster management, and wait for this to update, and we'll see it's already stating that it's in the 1.24, but it's just gonna give us some of those provisioning logs. I didn't take a snapshot. I should have, because then we. It's in one of these resources here. Let me. SCaLE Rodeo.
And that snapshot is only of the etcd database. That is not backing up that WordPress database or the storage. It is only the etcd.
Once this comes up, I'll show you. It's upgrading. Yeah, because there's going to be like a list of resources. I wonder if we can go into the local and it would have it. Clusters. The snapshot would be stored in one of these like resources. I'll have to double check. But let's go into cluster management and wait for this to come back up. Cool. And are there any other questions you guys might have? I would note that there's actually ways to do this programmatically in newer versions of Rancher using things like Cluster API, which is an upstream tool, but we have created our own version of it called Rancher Turtles, because Turtles all the way down, because Kubernetes all the way down. So that's available as of 2.82. So again, this maintained Rodeo has not been up to date. We're on 2.73, but did I just click update again or something? No.
So if I wanted
Yeah.
to utilize infrastructure as code
Mm-hmm.
to do everything that we just did,
Mm-hmm. Yeah, we do have that ability with Terraform, and then also that cluster API CAPI. So that's something to look into. So like, let's see, Turtles all the way down. I love that my taxes showed up first. Rancher. Let's see if it shows up with that. Nope. Turtles. So with this right here, Turtles, you can actually go in and follow along with the documentation and README, and you can actually do it like programmatically. So, yep, teaches you how to set up the Rancher server itself, installs an operator, and so forth. So if we come back into here, I think, did I just accidentally kill this? We'll wait for this to come up. And are your guys' clusters still configuring, or is it just mine? Because it was ready for a second, then I accidentally pressed something, so I think I messed it up. Still updating? Cool. And now mine is running and active. Cool. So this is where the snapshots would look like in the UI. So I just clicked create snapshot, and then if we, should refresh, and we should have a snapshot that we can reference. There it is. So this one was just created. We can restore to it, etc. So that's where those snapshots would be located. Cool. And then, are there any other questions? That's pretty much, we've reached the end all be all. If you go to this next page, don't click finish because it will tear down everything. And if you already have, I'm sorry. But, so, this will be available. You guys can still mess with it. You can go in and like install Quake or Tetris, and we could just like mess around, have some like just freeform Q&A. It's kind of what we like planned for the rest of it. So yeah, if we come hang out with you down there. So yeah, thanks for listening to me talk for 3 hours. Thanks. And Brian too, obviously. Yeah. Probably. If it gets stuck in reconciling, you could do some. You could probably just restore it to a backup. So if you go into the local cluster, there's some extra tools for just the local cluster in that apps catalog. So if you go into charts and you observe in here, there will be Rancher backup. Let me see. Yep, Rancher backups. So this is a way to actually back up the entire Rancher instance. Oh wait, this is in reference to Rancher going down. If it was reconciling, you would just basically tear it down, and you should be able to follow like the snapshot. Right, you should be able to follow the snapshot documentation to bring up that cluster referencing that snapshot. Does that make sense?
So if you have a snapshot, your entire cluster could blow up. You could build a brand new cluster, it would store from a snapshot, and it will remember all the things you deployed, all your resources, and put you back up and running. It won't remember your WordPress database, because that will run a different story. But the SCD snapshot that we did will capture everything about your cluster, and you can set those up to snapshot 100 times a day.
Yep. And like it says here in the docs, you can do it locally on the etcd node, which Brian had mentioned earlier, or you could go to a backup store that's S3 compatible.
Yeah, I set all mine to be backup to like S3 stores everything. So because when my node dies, my backup is off. But I can always get those backups.
And then there's obviously ways to like set up recurring snapshots, but yep. Cool. Any other questions? Yeah. Yeah, we do. So as it stands, you have to use Rancher to then create a harvester cluster. And you essentially would just boot up that ISO on some nodes, and then you can import that cluster into your Rancher server. So let me.
So the harvester install is done via media on a bare metal server. And it's bare metal, it boots up and creates a business for you.
Yeah, you would just be adding another layer, yeah. Say that last bit again. Yeah. Yeah, exactly. You can use so you can always. Yep. And So, and if you have a harvester cluster, you can always use, so if you create a harvester cluster, you would have those bare metal nodes, you would import it into the, what was virtualization management right here. And as you can see here, I don't actually have one. It's just gonna say, run this command into the harvester cluster, but you'll be able to create VMs, etc. But the cool part is then you can create more clusters from that harvester cluster. So it's like using Kubernetes to make more Kubernetes. So it's like similar to vSphere in that sense, but yeah. You can use that cluster API to bring up bare metal clusters. Yeah. Yeah, so you can use it alongside Rancher. So yeah, this is our Terraform provider. Just had a release like last week, so. So with the production stuff, you essentially would just have more resiliency. You would, I'll show you, I'm gonna unplug this briefly and then I'll get go to like what a more production ready Rancher would look like. So for instance, like with the local cluster, this is this has 3 nodes, and it's best practices for Rancher specifically to have a 3-node cluster with all roles is what we prefer. There are instances like I was just on a customer site and they had to deploy more worker nodes in their Rancher cluster, so they have 2 extra nodes to manage the Grafana application because they have so much data aggregating through. So that's like more production ready. You would have things like you'd have a vault for things like secrets. You could have a registry like Harbor to have your own container images so that you wouldn't be pulling from a public repository. But the big thing is like if you wanted to create a cluster that was downstream, so if I went into this, let's see, and wanted to create like a downstream cluster in Amazon that was actually should handle the workloads for a production cluster. Let me Oh, what creds are these? AI. So this is referencing like my cloud credentials in AWS. Huh? Yeah, I was. Thank you. Sorry. Apparently it doesn't automatically mirror. It just wants to goof me. I'm just sitting here talking. Oh, thank you. Yeah. So, for instance, I'm in a cluster, so I wanted to first show you this, the local cluster. We have 3 nodes here with all roles. That would be more best practices. And then you'd obviously want like a DNS because you don't want to expose like the external IP address like we are with the hobby farm. But let's go back and I can show you what like deploying a cluster would look like. That was just for the Rancher deployment. And best practices for Rancher deployment is 3 with all roles. But if you wanted like a production-ready Kubernetes downstream cluster, I can show you what that would look like. You could spin it up in moments using RKE2. And then also this is going to be using EC2 instances. So I'm going to deselect that. I'm going to make not 31. That'd be crazy. You could, and then your bill would be insane. I'm going to leave that at Rancher VPC. Default there, default there. I'm going to name this test cluster. I'm going to add a pool. So now this is going to have 3 separate pools. I'm going to create a pool for control plane nodes. And see over here how it has these little notifications. So that's saying like, hey, this is highly available because control planes didn't necessarily meet that standard with just 2. But if you actually add another pool, oh, I need to select a VPC. I'll name this to comp, and then here. And then we're going to make our data. You could actually combine this with the control plane. That technically would meet that standard. And just click create. And it will sit there for a second. And so this is version 2.82. And we have extensions in here. I'm going to let that spin up. But if you actually come into like, we have extensions like Elemental installed. So you could go manage the OS. You can go create your own operating system that's specifically been containerized for, right there, for like Kubernetes. You could use Harvester there. You could also install the operator CAPI into this cluster. So it's pretty sweet. But let's go back to the home. We obviously have a lot of pending right here. But this is the cluster I just barely started, and that we'll see how long it takes to come up, but it should be fairly quick. And that will be a representation of what a production-ready cluster would be. And then, yep, because it's like leader election based, like finding quorum. Yeah, cool. And then if you wanted like day 2 operations, it would be like installing like monitoring, and ingress like Nginx. No, that's literally how you would do it in like a production cluster, yeah. Other than, there's other like things that you can do inside of Grafana, like I said, you could federate it, and you could have a whole bunch of clusters all feeding into one monitoring application. But pretty much just following along with like, you'd create a Longhorn, so you have a CSI, like a default storage. You'd create OPA a gatekeeper to do the policy, manage those policies, so people have access to the cluster, et cetera. So things like that. So there's, I mean, first things you could always reference our documentation. If you wanted to find like information on actually like are you talking about like how to get a up-to-date Kubernetes, or not up-to-date, a production-ready Kubernetes cluster going, or anything from like Kubernetes.io, Reddit's Kubernetes threads are always good. We do like blog posts at SUSE on what kind of toolings we use. It's all over, man. There's not like, yeah. So, yeah. But, oh, and if we go over here, we should have a cluster spinning up, unless I'm out of my, unless my credentials are wrong, which they might have. It's been a second since I just was managing my IAMI on AWS, so I might have broke this. But yeah, cool. I mean, again, docs links are right here, so you could use like container security. All this stuff is essentially more like day 2 operations. The big thing I like to reference is like continuous delivery with Fleet. It will have a repo in, oh, let's go here. So if we come into this global tool, you can actually create Git repos, and the moment that you add a label to a cluster, it'll automatically take these repos and deploy it to that cluster. So if you have, and so that helps with like kind of getting up to speed with day 2 operations, specifically because you could just create a whole bunch of Helm charts. And the moment you update it, it will be referenced by Fleet. And then on top of that, the moment you add a cluster, a label to the continuous delivery, it'll label the cluster and deploy all of the applications within these repos. So, oh, and if you're looking for an NVIDIA GPU operator, we actually do support that on RKA2. So you can spin up your AI ML workloads on RKA2 clusters if you have GPUs in those nodes. And that operator like obviously works with like, I think it detects like CUDA and everything and gets it going. So yeah. Yeah, that operator, you'd have to install the operator, but yeah, exactly. So, yep. You're welcome. Yes, in the hobby farm. Yep. Yeah. Yep. But again, if your flavor is like Ubuntu or something, we like to be interoperable. You can go ahead and deploy it on there. There's like a support matrix for which ones are. So like this version of Rancher. So it's saying you can deploy on these versions of Kubernetes, these distros, and then you can deploy. Let's see. So then you would look at what those Kubernetes clusters like. So for instance, if you wanted to deploy on RKE2, these are all the repositories that we support, or not repositories, Linux distributions that we support. So you can deploy on Ubuntu, Rocky Linux, RHEL, CentOS, Oracle Linux. Cool. Yeah, you're welcome. Oh, and then that cluster, we just brought up a whole, yep. So this one is all in the cloud. This is all in AWS. And the one cool instance about that is you can actually just come in here and scale up and down nodes. So instead of having to like go in and add one manually and then run a command. Yeah. Yep. And then this one's received its IP address. You can actually SSH shell if you provision them through Rancher. You can actually go into the nodes and start running commands just from within Rancher. Again, you can also go to the cluster itself at the top. Once this is deployed, you can go into that Explore button, and you can run things on that kubectl shell. But, yeah. Yeah, you're welcome. Nice. use like predetermined groups in like Azure. So we use. Yeah. What?
Can we add another node on this cluster?
Yeah. Well, why? Right now?
Yeah, and Hobby Farm.
Oh no. We would have to. We could just try signing in and registering again, and then you could technically have 2 VMs that were provisioned. Does that make sense?
Yeah.
Because then you could just run that curl command really on both of those and then add it to the downstream cluster.
Yeah, but in your case, you would want to build that command and not run the curl command.
So these clusters, so all of these users are referenced in OpenLDAP, and if you went into, so for instance, a downstream cluster can have clusters and project members, and so you can actually add people via, let's see, so you could add them by individual users, and then you can also add them into groups. I just can't remember what the names of the groups are right now. So yeah, so then when those people sign in, you could actually make their permissions so scaled down that they could only see that one cluster, or you could have your Kubernetes admin that runs everything see all of them. And so like I run into guys that they're managing all of it, and they see all of it. They see the local cluster, they see the downstream clusters, and then what they do is like for some other teams that want to deploy their applications, they give them access to just a cluster, or even just a namespace within a cluster. So, but yeah, I wish I remembered what groups these are all called. LAT, AMS. Ah, see, so this is a group. So you could add anyone inside of that group in OpenLDAP to this cluster, and now they'd have access to that cluster. So, yeah. And if you look at it, they should already have a bunch of those. Yeah, you already have like all these groups. So. Hey, man, have a good one. Also, way to catch the freaking. He deserves a chameleon. Do we have any? You do? Yeah. No. Yeah, I am. Yeah. Well, that, and he also corrected me. I almost messed up and had them to run a command on the rancher node. Yeah. Yeah, that guy's going places. That guy's going places. Yeah. So the control plane does have, it does. I think, maybe I'm thinking of only during, that has a snow schedule. But this is in a cluster that I'll assign control plane, SCP.
Oh, as separate objects?
Yeah, yeah. Dude, my brain, I'm tired. Did you guys know where I came from?
No,
Dude, so Monday morning, fly out from Salt Lake to I went and hung out with Rivian with Jeremy.
Oh, nice.
Was there until Tuesday night. I went there at like 8 a.m. Didn't stop hanging out with the Rivian boys until like 9 p.m. Got out of my hotel at 4:30 a.m. on Wednesday. Flew to Salt Lake. Back home. Went and fed my cat. Got back on a flight at 9 p.m. in Salt Lake. Got here at 1.
And then scrambled to get here.
And then went to sleep and like woke up. I woke up late. I was trying to get up early. Cameron was messaging me. He's like, "Hey man, can we talk?" I'm like, "I'm not functioning." And then now I'm here. So, yeah.
Perfect. You made it.
Yeah, dude. Yeah, I did. Barely. So, dude, Rivian is sick. I test drove there.
Yeah, I was just gonna